Hello everyone, welcome back to Maths Marathon classes. This time I'll be doing 2024 JEE main January shift, okay, of binomial theorem. Binomial theorem is the first few topic. Many things are deleted from the NCERT textbook, but you have got to study more and more for JEE exams, like middle terms, coefficient of x for k, term independent of x, general term or r plus one term in the expansion of binomial, multinomial theorem, binomial coefficients, properties of binomial coefficients, many things you have to study, term independent of x, correct? Many things are remainder, finding a remainder when a number is divided by another number, correct? And also finding greatest term in the expansion, greatest coefficient, sum of the coefficients, all those things. Many things you have to study for JEE exams. We'll discuss a number of questions appeared from different concepts of this topic, binomial theorem. Okay, I'm doing 2024 JEE in January shift, binomial theorem. Okay, so the number of questions appeared from different topics. Based on binomial expansion, there is no question. General term, middle term, no questions are asked. Coefficient of x power k, there are 5 questions. Okay, and the terms in EP, no questions are asked. Multinomial theorem, no questions are asked. Properties of binomial coefficients, most important. NT's favorite question. Always you can expect more number of questions from properties of binomial coefficients. Please learn that 4 questions. General greatest term in the binomial expansion, not there. And even this is also NT's favorite question. Always you can expect number of integral terms or number of rational terms in the expansion. Okay, one question is divisibility also was a favorite question, but now it has become less, only one question. Earlier in 2023 JEE main, many questions were asked on divisibility. Okay, divisibility questions were many in that 2023 paper of January and April shift. Miscellaneous 2 questions. Altogether we have 13 questions, okay, and one question there is a faulty question also. So I'll be discussing 12 questions with correct answers, okay. One question there is a mistake done by NTA, so the data is insufficient in that, okay. So altogether we have 13 questions. Out of that 12 questions I'll be solving completely. One question I cannot solve because there is a mistake in the question, error in the question itself, okay. It's a faulty question I can call. So we'll discuss the questions one by one. It's one of the interesting topic and easy topic to score marks. Okay, almost one question you can expect every time. Sometimes you can expect 2 questions in each of the shifts. Okay, in one shift I can tell. So the first question we'll take now. Coefficient of x power 30 in the expansion of this is to find out. X not equal to 0 is given to be alpha. Find mod alpha. So whenever they ask mod alpha, that means there is a, and it's a numerical type question, integer type question. So mod alpha, if they ask, means if it is a numerical type question, I can make a slight guess that alpha will be a negative integer. That's why they ask mod alpha. That is one hint I can tell you about this. So want to find the coefficient of x power 30 in this little lengthy question, okay, this one. So numerical type question. So what we'll do is I'll simplify each of this bracket. I mean the first bracket I'll simplify by taking LCM. Second and third bracket I can write direct general term in that. And you must know in the binomial expansion of a plus b power n, the general term is given with this. If you know a plus b to the power n, the general term, the tr plus 1 we call. Tr plus 1 is the r plus 1th term. R plus 1th term or general term in the binomial expansion of this is given by NCR a power n minus r b power r. That you have to learn. Okay, NCR a power n minus r b power r. Okay, this is the formula I'll be using in this problem, and many of the problems I'll be using this whenever you want to write the r plus 1th term. Or it's also called a general term in the binomial expansion of a plus b power n. So I'll be using this formula to work out this problem. First we'll simplify this. Inside this bracket I can take LCM as x, correct? If you take LCM as x, what is 1 plus 1 by x to the power 6? 1 plus 1 by x to the power 6 is, x is common denominator, right? So x plus 1 whole divided by 6. That's equal to x plus 1 power 6 by x power 6. X plus 1 power 6 is same as 1 plus x whole power 6, correct? This is same as 1 plus x whole to the power 6 divided by x power 6, like this. 1 plus x whole power 6 by x power 6. So I'll write this expansion, the expression given. I'll call this as JEE, general expression. Okay, a given expression. Given expression is JEE. JEE is a given expression. Given expression is equal to 1 plus 1 by x to the power 6 is simplified like this. Okay, 1 plus x whole to the power 6 into 1 plus x square whole to the power 7 into 1 minus x cube whole to the power 8 divided by x power 6. Because of its multiplication, I can whole divide by x power 6, both one and the same. Dividing 1 plus x power 6 by x power 6, dividing this by x power 6, same as dividing all this entire product by x power 6. So divided by x power 6 I can write. Our aim is to find coefficient of x power 30 in this, correct? Coefficient of x power 30 in this is same as coefficient of x power 36 in the numerator, correct? Denominator is x power 6. So I'll find coefficient of x power 30 in the numerator. Okay? Coefficient of x power 30 is required in this expansion. So I'll write the sentence here. Coefficient of x power 30 in the above expansion. Okay? In the above expansion. In the above expansion is the same as coefficient of x power 36 in the numerator. Coefficient of x power 36 in the numerator. 1 plus x power 6 into 1 plus x square to the power 7 into 1 minus x cube to the power 8. Okay? Coefficient of x power 36 in this product. Coefficient of x power 30 in this is same as coefficient of x power 36 in the numerator only I have taken. See the difference here. This and this compare. I didn't write the denominator. Denominator x power 6 I didn't write. So I made coefficient of x power 36 in this. So I write the general term in each of these expansions. 1 plus x power 6. Applying this formula. NCR a power n minus r b power r. So I'll use the notations R for this. Here S I'll use P. Okay. NCR for this R, for this S, for this P I'll use. My R is, I'll use S here. This R I'll use it as P here for writing the general term. So to find the coefficient of x power 36, first I'll write the general term in each of these brackets. So general term of, now I'm writing the general term in 1 plus x to the power 6 into 1 plus x square to the power 7 into 1 minus x cube to the power 8. I'll start from this side because there is no space here. General term in the expansion of 1 plus x to the power 6 into 1 plus x square to the power 7 into 1 minus x cube to the power 8 is equal to, using this formula, focus on this, NCR a power n minus r b power r. Compare each of this with a plus b power n. My a is 1 everywhere in each bracket, correct? Compare this a plus b power n, a plus b power n, a plus b power n. A is 1. 1 to the power, any number is 1, right? 1 to the power n minus r is 1 itself. So I'll write directly. This is 6CR a power n minus r. If you want to write 1 to the power 6 minus r into x to the power r. This expansion over. General term in this over. In this, write the general term. N is 7 here, correct? So 7CS I'll use. 7CS 1 to the power 7 minus s into x square to the power s. And coming to this last bracket, that will be 8CP, I'll write. 8CP 1 to the power 8 minus p, 1 to the power 8 minus p into minus x cube to the power p. That's a general term each of the bracket. 1 to the power anything is 1, so I won't write 1. 1 into any number, 1 into any finite number is that finite number only. So this will be equal to, I'll write like this, 6CR into 7CS into 8CP. Okay, I wrote the binomial coefficients first. I won't write 1 to the power because 1 to the power any number is 1, 1 into that number is that number only. Here I can separate this minus power p. This is minus 1 to the power p it is. Minus 1 to the power p. Here x power r, here x power 2s, here x power 3p, correct? Multiplying means adding the powers of x because bases are same here. X power r, x power 2s, x power 3p becomes x to the power r plus 2s plus 3p, correct? R plus 2s plus 3p, like this I get. Now I need to find coefficient of x power 36. To get coefficient of x power 36, equate this power to 36, okay? To get coefficient of x power 36. To get coefficient of x power 36, we take r plus 2s plus 3p. R plus 2s plus 3p is equal to 36. The power should become 36. And there is restrictions for the values of r, s and p. Correct? R is from the first bracket, no? R can take values from 0 to 6. And that too it is whole number, okay? So you can note down that R will take the values from 0 to 6. S is got from the second bracket. S can take the values from 0 to 7. Maximum value of S is 7. And P is got from third bracket, correct? P can take the values from 0 to 8. Maximum is 8. Of course, all are whole numbers only. With R, S, P are whole numbers. Don't have fractions or decimals in this interval. Okay, understood that R, S and P are whole numbers. With R, S, P belonging to I, I'll call integers. Integers in this interval. Okay, 0 to 6 for R, 0 to 7 for S, 0 to 8 for P. So these are the restrictions for R, S and P according to the binomial expansion. You can't go beyond this, correct? That's understandable. Now I'll write down different values of R, S and P for which this equation is satisfied. See, P I'll start 8. Maximum value of P is 8. So if you take P is equal to 1, what are the different possibilities of R and S you write down? Okay, like that we go on continue. P equal to 7, 6. At some stage it is going to stop. It is going to end. Then I can find out all the values of binomial coefficients and I can write down the coefficient of x power 3rd in this. Little bit of more calculative, of course it takes more time. 3 to 4 minutes is required to solve this problem if you do it faster also, correct? With accuracy, fast and accuracy is required. Simply doing fast also will be doesn't make sense because you should be fast and accurate, correct? You can't be accurate and slow, correct? So time factor is also important in competitive exams. It should be fast and accurate. Both are matters and lot of concentration is required. If you lose a little bit of concentration, then gone. You can't get the right answer, correct? So concentration is also important. So now I'll take P as 8 first. Cases I'll discuss. P equal to 8. What is R plus 2S you find out. Then you can write down the values of R and S from that. Okay. Starting with P is equal to 8. P is equal to 8. Case 1. Case 1. P is equal to 8. If P is equal to 8, what happens? R plus 2S. P is 8. 3 into 8 is 24. Correct? R plus 2S plus 24 equal to 36. R plus 2S. Then R plus 2S will be R plus 2S becomes equal to how much? 3 into 8 is 24. 36 minus 24 is 12. So R plus 2S will be equal to 12. R plus 2S will be equal to 12. R can take values from 0 to 6. S can take values from 0 to 7. So using that, I'll write the table for this. R, S and P. R, S and P. P is fixed as 8. Correct? P is fixed as 8. Suppose R is 0. 0 plus 2S equal 12. 2S is 12, so S is 6. If R is equal to 1, what happens? 2S becomes 11. 2S is 11, so 11 becomes, S becomes non-integral value. If you put R is equal to 1, 1 plus 2S is 12, so 2S is 11 it becomes. S is 11 by 2. 11 by 2 is not permitted, correct? It should be integer. So I can't take R as odd number in this case. I'll take R is equal to 2. So 2S will be 12 minus 2, 10. So 2S is equal to 10 means S is equal to 5. P is fixed as 8 only. Correct? Once again, I can't take R as an odd number. If you take R as 3 here, 12 minus 3, 9. 2S is 9. S is 9 by 2. 9 by 2 is not an integer, so we can't take. So we'll go for R is equal to 4. Yes, P is fixed here as 8. Suppose you take R is equal to 4, 12 minus 4 is 8, 2s equal to 8, s will be 4. Correct? P is fixed as 8. Again, I can't take R as 5. If you take R as 5, 2s will be 2s becomes how much? 7, odd number. 2s is odd number, means s becomes odd number by 2, correct? Which is not an integer. So I'll go for R equal to 6. R equal to 6 means what happens? 12 minus 6 is 6. 2s equal to 6, s will be equal to 3. Further I can't have, correct? If you can't go for R is equal to 8 because the maximum value of R is 6 here. R maximum value is 6. So this case is over. Case 1 for P is equal to 8 is over. Okay. Next I'll take for P is equal to 7. Case 2 for P is equal to 7. If P is equal to 7, what happens? What is my equation? R plus 2s you find out. R plus 2s is equal to how much? R plus 2s is equal to, for P equal to 7. 3 into 7 is 21. 36 minus 21 is 15. R plus 2s is 15. R plus 2s is 15, right? Now write the different values of R and S with P as 7. So I'll do table for this. R, S and P. P is 7 fixed. R can I take 0? If you take R equal to 0, 2s becomes 15. S is 15 by 2, which is not an integer. So not possible. R equal to 0 is not possible. I'll take R is equal to 1. If you take R is equal to 1, 2s becomes 14. S is 7. P is fixed as 7 here. R is equal to 2 if you take. 2s becomes 13. S is 13 by 2, which is not an integer. So not possible. So I'll take R is equal to 3 here. If you take R is equal to 3, 2s becomes 15 minus 3, 12. So S will be 6. Is possible. Again, you can't take R equal to 4 because 2s will be 11. If you take R equal to 4, 2s will be 11. S is 11 by 2, not possible. So I'll take R is equal to 5. If you take R is equal to 5, 2s will be 10, S will be 5. P is already fixed. I can't go for R equal to 6. If you take R equal to 6, S becomes non-integral value. If you take R equal to 7, it's not possible because the maximum value of R is 6. So this case also will end up here with 3 possibilities. Next I'll go for P equal to 6. Case 3 for P equal to 6. If P is equal to 6, what happens? P is equal to 6. Then R plus 2s. R plus 2s becomes equal to how much? When P is equal to 6. Correct? P is equal to 6. My equation is what? R plus 2s plus 3p. P is equal to 6. 3 into 6, 18. Yeah, 36 minus 18 will be 18. Correct? R plus 2s becomes 18. So we'll do the table for this. R, S and P. P is already fixed as 18. P is fixed as 6. So R plus 2s is 18. You can take R equal to 0. 2s becomes 18. S becomes 9. S is 9, not possible because maximum value of S is 7. So you can't take R equal to 0. I can't take R equal to 0. If you take R is equal to 1, 2s becomes non-integral value. 2s becomes 17, odd number. S is 17 by 2, which is non-integral value. So you can take R is equal to 2, you can try. If you take R is equal to 2, 2s becomes 16. Correct? 2s is 16, S becomes 8. S equal to 8 is also not there. S maximum value is 7. Correct? So I'll take R is equal to 4. R equal to 3, once again not possible. If you take R is equal to 3, 2s becomes 15. S is 15 by 2, which is non-integral value. So I'll start with R is equal to 4. R is equal to 4, 2s becomes 14. S is 7. S equal to 7 is there. R equal to 5, 2s becomes 13. S is 13 by 2, which is not possible. So I'll take R is equal to 6. If you take R is equal to 6, 2s becomes 12. S equal to 6 I'll get. P is also 6. Correct? 6 plus 12 is 18. These are the possible values. Correct? Can't go more than 6. And S is maximum 7. So all the cases are covered with this. So here we got 4 possibilities. Here we got 3 possibilities. Here we got 2 possibilities. So now with these values of R, S and P, I need to write the coefficients now. Coefficients. Then I have to take sum of the coefficients to get the answer. Okay. So that will get the coefficient of x power 30 in that case. In each of these cases I am getting x power 30. I need to sum up to get the coefficient of x power 30 in this product. That is alpha. And I have to find mod alpha. Okay, I can give the hint that alpha can be negative because there's modulus of alpha. Alpha most of the time will be negative whenever there's mod alpha, and that is a numerical type question, not for multiple choice question actually. Numerical type question is given in that case. So I'll write down the values now for this, the coefficients. I need to write the coefficient of x power 30, correct? So coefficient of x power 30 you want. So you focus on this and write down the coefficient. 6CR, 7CS, 8 power P, minus 1 to the power P is there, correct? Minus 1 to the power P. Here what is the coefficient? Here the coefficient is going to be 6C0 into 7C6 into 8C8. Minus 1 to the power 8, that is plus 1, correct? Here, when P is even number, minus 1 to the power even number is plus 1. Here, also P is even number, minus 1 to the power even number is plus 1. Whereas here, P is odd number, so minus 1 to the power odd number will be minus. In that case, I'll take it. Here, this will be coefficient is 6C2, 7C5 into 8C8. Here, the coefficient is going to be 6C4 into 7C4 into 8C8. Here the coefficient is going to be 6C6, then 7C3 into 8C8, correct? Here the coefficient is going to be, I'll write minus sign because of this, minus 1 to the power 7. Because of this factor, minus 1 to the power P, I'm writing P is odd number, minus 1 to the power odd number becomes minus, correct? So this will be minus. So this will be minus 6C1 into 7C1 into 8C1. This is minus 6C3 into 7C6 into 8C7. Here it's 8C7, no? Sorry, mistake happened. Here it is. Minus 6C1, 7C7 into 8C7. Here coefficient is going to be minus 6C5 then into 7C5 into 8C7. Okay. Minus sign, hope you understand why, because of minus 1 to the power P was there, no? Minus 1 to the power P is odd number, yeah? Minus 1 to the power odd number is minus. That's why I keep minus everywhere. Okay. Here I don't keep because minus 1 to the power 6 becomes plus 1. Here the coefficient is going to be 6C4 into 7C7 into 8C6. Here it is 6C6 into 7C6 into 8C6. Connect R, S and P. 6C6, 7C6, 8C6. Clear, no? So now take the values of this and add it up. Write down the values of this and take the sum of all the values. That will be the coefficient of x power 30 in this product. Hope it's clear. Correct, no values. R value, S value, P value, all I am going to substitute. I am going to substitute in this equation. In this equation, I am substituting the values of R, S and P and writing. So that I get the coefficient of x power 30. Correct? Zero 6 8 2 5 8 4 4 8, correct? No, 6 3 8 1 7 7 3 6 7 5 5 7 6 7 8, correct? 4 7 6 6 6 6. So now I'll take the sum of all these things. Therefore, coefficient of x power 30 is, therefore, coefficient of x power 30 in the given expansion is, coefficient of x power 30 in the given expansion, the given expression I can write. In the given expression is equal to what we have. Write down these values. 6C0 is 1, 7C6 is 7, 7C1 7, 8C8 is 1. So 1 into 7 into 1, 7, correct? 1 into 7 into 1, that is 7. Plus, next one is what we have. 6C2 is 15, 6C2 is 15, 7C5, 8C8, correct? 6C2, what we got? 6C2, we got the values 6C2, 7C5, 8C8. 6C2, 7C5, 8C8. Correct? 6C2 is 15, 7C5, 7C2, 21, 8C8 is 1. So this will be 15 into 7C5, 7C2, which is 21 into 1. This is 210 plus 105, 315 you get. Correct? This is 315. 315 I'm getting. 21 into 15, 210 plus 105, correct? No? Next one is your 6C4 is same as 6C2, 6C2 is 15, 7C4 is same as 7C3, 21, 8C8 is 1, 21 into 15, correct? 7C4 is 21, 6C4 is same as 6C2, 15, 21 into 15, how much is that? 21 into 15. 21 into 10 is 210, 210 plus 155, 105, 21 into 15, is it correct? No, 6C4 is same as, yeah, 6C2, 7C4 is same as 7C3, 7C3 is 35, correct? 7C3 is 35, this is 35. 21 into 35, how much is this? 21 into 35 I'm getting, correct? No, 6C4 into 7C, 6C4 is 62, 15, 7C4 is 7C3, 7C3 is 7 into 6 into 5 by 3 factor, 35 comes, 8C8 is 1. So we get 35 into 21, 5 into 1, 5, 2 into 5, 10, 21 into 3 is 63, correct? 5, 3, 7, 735 I get, correct? No, 35 into 10, 350, 700, 735 I'm getting. Next term is how much? Coefficient. 6C6 1, 8C8 is 1, 7C3 7, 7C4, 7C3 only can keep, 35 it is. 35. Next term is how much? Minus 6C1 is 6, 7C7 is 1, 8C7 is 8C1, 8C1 is 8, 8 into 1 into 6, 48, minus 48, minus 48. Correct, no? 8C7 is same as 8C1, 8, 7C6 same as 7C1, 7, 7 into 8 is 56, 56 into 6C3 is how much? 6 into 5 into 4, 6 into 5 into 4 divided by 3 factor, 20 it is. 6C3 is 20. 6C3 is 20. 20 into 7 into 8. 7 into 8 is 56. 56 into 20. 1120. Minus 1120 I get. Next term is here. 6C5 same as 6C1, 6. 7C5, 7C to 21. 21, 8, 6. 8C7 is 8C1, 8. 8 into 6. 48. 48 into 21 I get. This is 8. 8C6 same as 8C1. 8C1 is 8. 6C5 same as 6C1. 6. 8 into 6. 48. 48 into 21 I get. 48 into 21 is how much? 48 into 21. 48 into 1 is 48. 48 2s is 96. 8. 6 plus 4, 10. 10. 1008 I get. Minus 1008. Next term. Come into this. Sorry. Come into this. 6C4 is same as 6C2, 15. 7C7 is 1. 8C6 same as 8C2. 8C2 is 8 into 7 by 2, 28. 28 into 1 into 15. 28 into 15 how much? 28 into 15. 28 into 15, that is I think 420, correct? 280 plus 140, 420 it is. Last one, this value 6C6 is 1, 7C6 is same as 7C1, 7C1 is 7, 8C6 same as 8C2, 8C2 is 28, 8 into 7 by 2, correct? No, 28, 28 into 7, that is 28 into 7 is 196, correct? No, 28 into 7, 28 into 7. 7 into 8 is 56. 5 carry. 14 plus 5, 196. Yeah, 196. Add all these things to get the answer. This will be 322. This is 760. Correct? 322, 760, 322 plus 760 plus 420 plus 196. This will be 8. 8, 10, 19. 1 carry 4. 4 plus 7, 11, 15, 16. 1698 I get. Right now? 1698. And these terms I need to add. Correct? No? Addition is correct. 8, 8, 10, 19, 1 carry 4 plus 7, 11, 15, 16. Adding these negative terms. 48, 1120, 1008. 1120, 1008 and 48. 8 plus 8 is 16. 1 carry 3 plus 4, 7, 1, 2. 2176 I get. Minus 2176. This will be equal to how much? 1698. 798, 898, 998. 302. 302. I think I made a mistake of it. 4 plus 7, 11, 15, 16, 1698. 322, 735, 760, 420, 196. 8, 8, 10, 19, 1 carry. Correct, no? 4 plus 7, 11, 11 plus 4, 15, 16, 1698, 2176. Any mistake has happened? Just calculation. Just check. 6C61, 7C67, 8C2 is 28. 28 into 7, 252. How much I get the difference between these two? 1698 minus 2176. I think small mistake has happened here. This is 1498, 315, where I got 315 it is. 315, I wrote 550 now what? This term is how much? 315. 735 I wrote. 735 from this. 6C4 is 6C2. 6C2 is 15. 6C2 is 15. 7C4 is 7. 7C3. 7C3 is how much? 35. 35 into 15 it is. 35 into 15, how much I got? I made a mistake. 35 into 21 I wrote. This was a mistake. I think 35 into 15 I get. 35 into 15 is going to be 35 into 5 is 175. 35 into 135. 525 I get here. Not 735. 525. This is 525. Okay. 525. So this will be 525 means this will be 525 plus 315, all those things if you add, 525, 560 you'll get that. That means 1498 will get. This will be 1498. This is 1498 because this will be 560. This is 560. So I'll get 1498. 1498 minus 2176 I'll get. Small mistake is enough to spoil the answer. 1498. 1498 minus 2176. I'll get this difference as minus how much? 502. 502 plus 176. 678. Minus 678 I get. This is my alpha value. Alpha according to the question. Alpha is the coefficient of x power 30. Want to find mod alpha. Alpha is minus 678. Therefore, mod alpha, mod of minus 678 is plus 678. That's the answer. Small mistake happened here. Well, calculation rest all are done correctly with patience. Correct? I wrote this product was wrong. 6C4 is 6C2, 15. 7C4 is 7C3. 7C3 is 21. I wrote 35. It was a mistake. Right? 7C3 is 7 into 6 into 5 by 3 factor. 30. 7C3 is 6C4 into 7C3. 7C3 is 35. 35 into, yeah, 7C3 is 35. 35 into 15, that is 325. Correct? 35 into 15, which is 325. I wrote 35 into 21, that was a mistake happened. I wrote 6C4 as 21. 6C4 is 60 to 15, it is 15 into 25. 15 into 35, that is 525. I wrote, this is a small mistake happened actually. I corrected it now. So answer is mod alpha equal to 678. It's a time consuming question actually. So lot of time is required. With patience you have to do it, and only it's possible to get the answer. Question asked on 1st of February, first step, JEE in 2024. Please make a note. So lengthy it is. Finding coefficient of all the terms. In each bracket find the coefficient and equate the power of x to 36. Want to find coefficient of x power 30 is, which is same as coefficient of x power 36 in the numerator. Okay, so get the answer. Move on to the next one. Question number 2. Let m and n be the coefficients of the 7th and the 13th term respectively in the expansion of this. Want to find n by m to the power 1 by 3. Want to find this. So I'll be using the general term tr plus 1 here. Tr plus 1 is ncr a power n minus r b power r, same formula. This is a plus b power n, compare. Okay, compare this with what is the given expansion. Comparing this with a plus b power n, I'll write down the values here only. A plus b power n, you compare. What is a? A is 1 by 3 x power 1 by 3. B is 1 by 2 x power 2 by 3. 1 by 2 x power 2 by 3. Then n is 18, correct? N is required for me. N is 18. A, B and n. N is 18. Now write the general term in this expansion. Tr plus 1. Tr plus 1 is ncr a power n minus r b power r. Tr plus 1 is equal to ncr a power n minus r b power r. Correct? Want to find the 7th and 13th term. Coefficients of 7th and 13th term are given to be m and n respectively. So to find the 7th term, T7, we put r is equal to 6. Want to find coefficient of T7 and coefficient of T13. 7th and 13th term, correct? So T7 is T6 plus 1. T6 plus 1. N is how much? N is 18 here. N is 18. 18C, R is 6. 18C, R is 6. A how much? A is 1 by 3 x power 1 by 3. A is 1 by 3 x power 1 by 3 to the power. N is how much? 18. Minus R is 6. B is how much? B is here. 1 by 2 x power 2 by 3. B is this. 1 by 2. 1 by 2 x power 2 by 3. Whole to the power. R is 6. Simplify this. What do you get? Is equal to 18C6 1 by 3 to the power 6 x power 1 by 3 power, sorry, 18 minus 6, 12, no? 18 minus 6, 12. One by 3 to the power, 18 minus 6 is 12. 1 by 3 into 12, the powers gets multiplied. 18 minus 6, 12. 12 into 1 by 3 is 4, x power 4. 1 to the power 6, 1. Here this 2 to the power 6 into x power 2 by 3 power 6. 2 into 6, 12. 12 by 3 is 4. X power 4 is going to cancel. Correct? So what you get is 18c6. 18c6. 1 by 3 power 12 into 2 power 6. I get like this. That's the coefficient of 7th term in this expansion. Also find the coefficient of 13th term. T13 coefficient I want to find. Here it's independent of x actually. Correct? Sometimes it may depend on x also. 13th term will find out. 13th term is T13 is equal to T12 plus 1. So my R is 12. If we compare to T R plus 1, R is 12. N is 18. So 18C12 is 18C12. A is 1 by 3 x power 1 by 3. 1 by 3 x power 1 by 3 to the power 18 minus 12. A power n minus r into b power r. 1 by 2 x power 2 by 3 to the power r is 12. Simplify this. What do you get? This is equal to 18c12 1 by 3 to the power 6 x to the power 1 by 3 into 6. 18 minus 12 is 6. 1 by 3 into 6 is x square. Correct? Here 1 to the power 12 is 1. This is divided by 2 power 12. Here x power 2 by 3 power 12. That is x power 24 by 3. X power 8 it becomes. So what I get from this? This is equal to 18c12. 18c12. 1 by 3 power 6 into 2 power 12. Correct? X square by x power it becomes x power minus 6. X square by x power it is x power minus 6. I want to find coefficient of 13th term. So coefficient means don't write x power. Only write the numbers. Correct? So from equations 1 and 2. From equations 1 and 2. I can write the coefficient of x power. Coefficient of 7th term is this. That is according to the question m. So m is this and n is this. This entire thing is m and this is n. Okay. So m and n I can write. M is coefficient of 7th term. N is coefficient of 13th term. Here don't write x power minus 6 because I am writing only the coefficients of 7th and 13th term. Here it's independent of x. Here it is dependent on x. So I'll write only coefficient and then to find out n by m to the power 1 by 3. Get the values of m and n. This is my m value and this is my n value. This is my n value. This is my n value, correct? This is my n value. And this is my m value. This is my m value. I need to find n by m to the power 1 by 3. So I'll find out n by m to the power 1 by 3 here itself. This part is not required anyway. It's sort of only for understanding. So finally we want n by m to the power 1 by 3, correct? N by m to the power 1 by 3. Correct? N is this 18c12. 18c12 into 1 by 3 power 6 2 power 12. Correct? 18c12 into 1 by 3 power 6. 1 by 3 power 6 into 2 power 12. M is how much? 18c6 into 18c6 into 1 by 3 power 12 into 2 power 6 whole to the power 1 by 3. Correct? 18c12 is same as 18c6 because you know NCR equal to NCN minus R. So these two will cancel out. Correct? And this will go up. What we'll get is 3 power 12 into 2 power 6. This will go to numerator. These two will cancel out because you know that NCR is equal to NCN minus R because of this. NCR equal to NCN minus R. So 18C12 is same as 18C6. Both are same. And this goes to numerator. This comes to denominator. 3 power 6 into 2 power 12 whole to the power 1 by 3. Correct? Here 3 power 12 by 3 power 6. 3 power 6 will cancel. 2 power 6 cancels. I get 3 by 2 whole power 6. I get 3 by 2. 3 power 6 will cancel. 2 power 6 cancel. 3 power 6 by 2 power 6. 3 by 2 whole power 6. I'll get 3 by 2 whole power 6 to the power 1 by 3. 3 by 2 whole power 6 to the power 1 by 3. That means 6 into 1 by 3, that is 2. 3 by 2 whole square. We get 3 by 2 the whole square, which is 9 by 4. Answer is option D, 9 by 4. 9 by 4 is the answer. Hope it's clear. Question asked on 1st of February, second shift, JEE in 2024. Please make a note. Just quite simple one. Just writing the general term and taking the coefficient using the formula TR plus 1 equal to NCR A power N minus R D power R. Move on to the next one. Question number 3. N minus 1 CR is given to be equal to K square minus 8 into NCR plus 1 if and only if. What is the condition for K I have to find out? Okay. So I'll be using the properties of binomial coefficient here. There is one beautiful property here. You must be knowing this. NCR is equal to N by R into N minus 1 CR minus 1, lowering the values. NCR is N by R into lowering it by 1, N minus 1 CR minus 1. So here NCR plus 1 I can write it as N by R plus 1 into 1 less 1 less. See, concentrate on this. NCR plus 1. NCR plus 1 could be written as N divided by R plus 1, N divided by R plus 1 into 1 less 1 less. What you get is N minus 1 CR. I'll be using that. Okay. So the given equation becomes N minus 1 CR, N minus 1 CR is equal to K square minus 8, K square minus 8 into what is NCR plus 1? N by R plus 1 into N minus 1 CR. So I'll write this as N divided by R plus 1, okay, into N minus 1 CR. N minus 1 CR. N minus 1 CR cancels, correct, on either side. So what we get is from this R plus 1 by N is equal to R plus 1 divided by N is equal to K square minus 8. Okay. I'll be using this equation to find the value of K. Call this as star. Also, you must be knowing when NCR is meaningful. NCR is meaningful if N should be greater than or equal to R. NCR is meaningful if R is greater than or equal to 0. Of course, N also should be positive. R should be greater than or equal to 0 and N should be greater than or equal to R. Correct? NCR is meaningful if R is greater than or equal to 0 and N should be greater than or equal to R. If N is less than R, it is meaningless. Correct? So these two things you must know about NCR when it is meaningful. Like finding the domain of the function, somewhat like that. So N minus 1 CR is meaningful only if N minus 1 is greater than or equal to R. And NCR plus 1 is meaningful if N is greater than or equal to R plus 1. N is greater than or equal to R plus 1 is same as N minus 1 greater than or equal to R. So from this one condition I get that N minus 1 CR and NCR plus 1 both are defined, both NCR, both N minus 1 CR and NCR plus 1 are both defined for, both of these are defined for N minus 1 greater than or equal to, the same as N is greater than or equal to R plus 1. N should be greater than or equal to R plus 1. That is one condition. In other words, I can tell R plus 1 by N should be less than or equal to 1. Correct? From this, I can write R plus 1 divided by N should be less than or equal to 1. So R plus 1 by N should be less than or equal to 1. This condition I will apply in star. Therefore, star implies this is less than or equal to 1. This is nothing but K square minus 8. Correct? This expression R plus 1 by N is nothing but K square minus 8 from star. Therefore, from star I am getting K square minus 8 is less than or equal to 1. Which is K square minus 9 less than or equal to 0. You can factorize this as K minus 3 into K plus 3. Correct? K minus 3 into K plus 3 is less than or equal to 0. The critical points are, one is k equal to 3, another is k equal to minus 3. Where this becomes 0 at 3. Where this becomes 0 at minus 3. Minus 3 and plus 3 are the critical points for this. I'm using Wevico method to find the solution for this. So if you take the critical points as minus 3 and plus 3 here, correct? Start from right side of 3. Extreme right side it is going to be positive, correct? Because coefficient of k square is 1, positive. So extreme right you start from positive. 3 is derived from this, k minus 3. Its power is 1, odd number. So sign changes, becomes minus. Minus 3 is derived from this, k plus 3. Its power is 1, odd number. Again sign changes, becomes plus. So where this product is less than or equal to 0 in the interval minus 3 to plus 3. So k belongs to the interval minus 3 to plus 3 according to this. K belongs to the interval minus 3 to plus 3. This is called 1. Also, I should consider the case that consider the condition that R should be greater than or equal to 0. I use N is greater than or equal to R. Now R should be greater than or equal to 0. Here R should be greater than or equal to 0, as well as R plus 1 greater than or equal to 0. That means both should be happen. I mean R should be positive or 0. R plus 1 is positive or 0. If you take the intersection of those two, I'll get R is greater than minus 1. R plus 1 should be positive. Even R should be positive, correct? R is positive. R is greater than or equal to 0 according to this. From this, R plus 1 should be greater than or equal to 0. That means I can tell R is greater than or equal to 0 and R is greater than or equal to minus 1. Minus 1 to infinity, 0 to infinity, integer values. So common to this is R is greater than or equal to 0. Common to these two is R is greater than or equal to 0. So instead of R is what? R is instead of R plus 1 we have, correct? So R should be positive. From this I can tell R should be greater than 0. That means R plus 1 will be, what is the condition for R plus 1? R plus 1 equal to 0 is possible to check. R plus 1 equal to 0 means I'll get R equal to minus 1, correct? R equal to minus 1 is not possible. I can tell that R plus 1 should be positive, correct? R plus 1 should be positive from these two. If you take R is equal to minus 1, this is not defined. This is defined for R equal to minus 1. If R plus 1 is positive, R will be, R plus 1 is say greater than 0. Don't take equal to 0. R plus 1 is positive means I can have the condition that even R is positive, correct? I'll use the condition that R plus 1 is positive here. R plus 1. If R is equal to minus 1 is not possible, correct? Minus 1 plus 1 becomes 0. That is possible, but here it is not possible. If you take R as greater than minus 1, if R is greater than minus 1, that means R plus 1 is positive. R plus 1 is positive. Okay. So that R plus 1 is positive means I get R plus 1 by N is less than or equal to 1. That condition is over. Consonant on this. R plus 1 is a positive means k square minus 8 should be positive because N is already positive here. Correct? R plus 1 should be positive, I can tell. R plus 1 is positive means I can use that condition and get another inequation for that. Using R plus 1 to be positive. Using R plus 1 positive. R plus 1 is greater than 0. That means denominator is already positive. So k square minus 8. R plus 1 is greater than 0 means R is greater than minus 1. Greater than minus 1 integer is 0. 0 is permitted, right? 0 is permitted for this. Correct? R plus 1 greater than 0 means R is greater than minus 1. Which is the integer greater than minus 1? 0. 0 is permitted for both. Correct? You can start with R equal to 0 onwards. R plus 1 greater than 0 means I can start my first integer as R equal to 0. Correct? R is greater than minus 1. So using this condition, R plus 1 is positive. N is already positive. So R plus 1 is positive. This entire thing is positive. So k square minus 8 will be positive from that. K square minus 8 is greater than 0. So what I get from this? K square is greater than 8. K square is greater than 8. That means k square is k square minus 8 I can decompose there itself using Wevico method. Wevico method I can apply here. K square minus 8 is greater than 0 means k minus 2 root 2 into k plus 2 root 2 I can write. Correct? I can write this as k minus 2 root 2 into k plus 2 root 2 is positive. By using Wavy-Comm method, I can write where this product is positive. This product is going to be positive in the interval minus infinity to minus 2 root 2 union 2 root 2 to infinity. Correct? Using Wavy-Comm method. Mark the critical points. One critical point from here, minus 2 root 2 I get. Another critical point again from this, 2 root 2. Correct? Right side of 2 root 2 is start. This is positive. Correct? 2 root 2 is got from this. Its power is 1, odd number. So sign thing this. Minus 2 root is got from this. Its power is odd number. Again sign thing this becomes plus. So using Wavy-Comm method, I got the interval like this. K belongs to the interval where minus infinity to minus 2 root 2. Minus infinity to minus 2 root 2 union 2 root 2 to infinity. This is equation 2. Okay. So from equations 1 and 2 we can find the common values so that I'll get the solution for the required. Okay. So take the common values. This is by using Wavy-Comm method I can tell. So 2 root 2 is a critical point from here where this becomes 0 at minus 2 root 2. Minus 2 root 2 plus 2 root 2 are the critical points. Extreme right is start positive and 2 root 2 is gone from here. Its power is 1, odd number. So sign changes. Minus 2 root 2 is got from this. Its power is 1, odd number. Again sign changes. So minus 2 root 2 and plus 2 root 2 are the critical points. So I'm getting like this. So according to these two, I can represent on the number line. So k belongs to which interval you see? From this minus 3 to plus 3, correct? According to this, k belongs to minus 3 plus 3 and this is minus 2 root 2 and plus 2 root 2 are the critical points there. So you can mark those minus 3, minus 2 root 2, this is 2 root 2 and 3. K belongs to minus 3 to plus 3. Minus 3 to plus 3. K is belong to minus 3 to plus 3 according to this. Even the endpoints are included here. Endpoints are included. And another one is this minus infinity to minus 2 root 2 union 2 root 2 to infinity. Take the common for these two. Common for these two is this. This is common and here I am getting common. So intersection of 1 and 2. 1 intersection 2 gives. 1 intersection 2 gives. K belonging to the interval. Minus 3 is included. Minus 2 root 2 is excluded. Correct? So it's a closed open interval. Closed open interval. Minus 3 to minus 2 root 2 union 2 root 2 to infinity. 2 root 2 is excluded. Correct? 2 root 2 is excluded. Open closed interval I get. Closed open union open closed 2 root 2 to 3. Correct? Minus 3 to minus 2 root 2 union 2 root 2 to 3. So this is the interval. K belongs to this. Correct? So according to the options they given this value 2 root 2 to 3. This is found. Correct? They not taken the negative values. Negative values of K is not included. This part is not there. But you can see this. K belongs to 2 root 2 to 3. Correct? 2 root 2 to 3 is there. 2 root 2 less than k less than or equal to 3. So properties of binomial coefficient is used here. Correct? R plus 1 should be positive and R should be positive. Both should be greater than or equal to 0. Equal to 0 is not there because when you put R equal to minus 1, this is not defined. This is defined for R equal to minus 1. So I take R plus 1 greater than 0. R plus 1 equal to 0 is not possible. For this it's defined, for this not defined. Both should be defined at the same time. So I am taking R plus 1 greater than 0. Equal to 0 is not permitted because for minus 1 this is not defined. N minus 1 C minus 1 becomes meaningless. This is meaningful for even R equal to minus 1. So I'll take R plus 1 greater than 0. So K square, R plus 1 positive means K square minus 8 should be positive because N is already positive, we know. R plus 1 by N is positive. Question answer on 27th of January, first shift, JEE in 2024. Nice question on properties of binomial coefficient. Move on to the next one. A denotes the sum of all coefficients in the expansion of this and B denotes the sum of all coefficients in another expansion. We know that sum of the coefficients is got by putting x equal to 1 in any binomial expansion. Just remember, sum of the coefficients in the expansion of, note that sum of all coefficients sum of all the coefficients, sum of all the coefficients in the expansion of, sum of all the coefficients in the expansion of f of x to the power n, right, is nothing but f of 1 to the power n. Okay, sum of all the coefficients in the expansion of f of x power n is f of 1 power n. That means you put x equal to 1. To get the sum of all coefficients, what you should do is just put all the variables equal to 1. If it is x and y, you put both x and y as 1. Here it involves only x. Here it is involving only x. So to get a denotes sum of all coefficients. So put x equal to 1 in this. A is equal to, put x equal to 100. Sum of the coefficients. 1 minus 3 plus how much? 10 into 1. 10, correct? To the power n. Just put x is equal to 1 in this. 1 minus 3 into 1 plus 10 into 1 square. 1 minus 3 plus 10 to the power n. 1 minus 3 is minus 2. Minus 2 plus 10 becomes 8. 8 power n. B is what? According to the question. B is the sum of all coefficients in this expansion. 1 plus x square power n. To get sum of the coefficients, put x equal to 1. 1 plus 1 square power n. Correct? 1 plus 1 to the power n, which is 2 power n. We can write 8 power n as 2 cube to the power n. 2 cube to the power n. Or you can write this as 2 power n the cube. Correct? 8 is 2 cube. 2 cube power n is 2 power n cube. So I can write a as 2 power n cube, which is 2 power n is nothing but b. They are asking to write the relationship between a and b here in the options. So 2 power n is b here. So a is b cube I am getting. A is equal to b cube, option A. Very simple question. CET level question, level 0 kind of question for JEE exams. Question asked on 27th of January, first shift JEE in 2024. Please make a note. You must remember that sum of the coefficients in the binomial expansion or multinomial expansion is gone by putting all the variables equal to 1. Sum of all coefficients you get. Whereas just put x equal to 1. Put x equal to 1, put x equal to 1, they get sum of the coefficients. Point to be noted. Move on to the next one. Question number 5. Coefficient of x power 2012 in the expansion of this set to find out. So first we'll simplify this. We can relate these to see 1 minus x into 1 plus x square. Here the power is 2008, here the power is 2007. That's some important observation. And you know the product of these two, it looks like a cube minus b cube formula. A minus b into a square plus ab plus b square. You know this formula, a cube minus b cube. What is a cube minus b cube? A minus b into a square plus ab plus b square. A square plus ab plus b square. Correct? So I'll write 1 minus x cube. 1 is 1 cube. 1 cube minus x cube is equal to 1 minus x, put a as 1, b as x, into 1 square plus 1 into x plus x square. Correct? So 1 minus x into 1 plus x square is 1 minus x cube. 1 cube is 1, 1 minus x cube. So I can write this given expression as 1 minus x into 1 minus x into G I'll call, given expression G I'll call 1 minus x power 2008, I'll write 1 minus x into 1 minus x power 2007 into 1 plus x square to the power 2007, so that I can merge these two. Correct? The product of these two I'll combine and use this formula, a minus b into a square plus ab plus b square, a cube minus b cube. Correct? This will be equal to 1 minus x into, this will be 1 minus x into 1 plus x square whole to the power 2007. Whole to the power 2007. A minus b into a square plus ab plus b square is a cube minus b cube. So this is 1 minus x into, this will be 1 minus x cube to the power 2007. Multiply 1 into this minus x into this. Correct? So 1 into this, that will be 1 minus x cube to the power 2007 minus x into this, x into 1 minus x cube to the power 2007. 1 minus x cube power 2007. Here if we expand this, no, all the powers of x will be multiples of 3 here. In the expansion of this, all the powers of x are multiples of 3. Here also, in this expansion, all the powers of x are multiples of 3, and we multiply it to x, it becomes x power 3k plus 1 form. X into x cube, x power 4. X cube, x into x power 6, x power 7. So the powers of x will be multiple of 3 plus 1. Here, in this expansion, all the terms will be powers of x will be multiples of 3, I can write. Powers of x will be multiple of 3. Will be multiple of 3. In this, all the terms will be having the powers of x as multiple of 3. That you multiply to x means the powers of x will be multiple of 3 plus 1. X power 1, x power 4, x power 7, such powers I'll get. Here, powers of x will be multiple of 3 plus 1. Powers of x will be multiple of 3 plus 1. Powers of x will be of the form 3k plus 1, right? Will be of the form 3k plus 1, where k is some natural number. Okay, k is some natural number. K belongs to n. With some restrictions are there. Lower limit for k will be 1, correct? 3 into 1. K belongs to natural numbers including 0. I can write, otherwise k belongs to the set only. From 0 to 2007 I can write. K belongs to the, because there are 2007 terms, k belongs to the set, correct? X cube, k belongs to the set 0, and you put k equal to 0, get x power 1. Next will be k equal to like that, k equal to 0, 1, 2, 3, it goes on till 2007. So multiple of 3 plus 1 in this expansion after multiplying to x. Here the powers of x will be multiples of 3, will be of the type 3k, will be of the type 3k, where k belongs to the set 0, 1, 2, etc. 2007. Okay. And what we want to find is coefficient of x power 2012. Want to find coefficient of x power 2012 in this. It is the same as this. So 2012 is not a multiple of 3 and it is not a multiple of 3 plus 1. 2012 will not take this form. Will not take this form. 2012 will take the form 3k plus 2. So we don't have power of x as 3k plus 2 in both of this. So coefficient of x power 2012 is going to be equal to 0. Answer is 0. There is no term containing x power 2012. Understood? Because 2012 is a number of the type 3k plus 2. 2010 is multiple of 3 plus 2. So coefficient of x power 2012 does not exist in this. Hence the coefficient is going to be equal to 0. Question asked on 27th of January, second shift, JEE 2024. Please make a note. Understood, right? Is that clear? X power 2012 does not occur because it is power of x is of this type. Here in this, the power of x will be of this type. X power 1, x power 4, x power 7, like that. And you will get x power 2011 will get in this. X power 2014 will get this. But x power 2012 you won't get this. Here the power of x is multiple of 3. X power 0, x power 3, x power 6, like that. X power 2010 you get. X power 2013 you get. You won't get 2012 in this. So x power 2012 is not found in this, not found in this. The coefficient of x power 2012 is 0. X power 2012 does not occur in the given expression. Okay. Hence its coefficient is 0. Numerical type question asked. Move on to the next one. Question number 6. 11c1 by 2 plus 11c2 by 3 etc. 11c9 by 10 equal to n by m. GCD of n comma m is 1. Want to find n plus m. This is a question based on the properties of the binomial coefficient. You must be knowing the binomial coefficient property. First you write this general term. General term will write. In terms of summation will write. See 11c1, 11c2, 11c9 it goes. Denominator is 2, 3, etc. 10. So 1 means 2, 2 means 3. Can generalize and write. Summation, the given expression is summation of r is equal to 1 to, r is varying from 1 to 9. Correct? There are 9 terms. R is 1 to 9. R is 1 to 9. What we have? 11CR by R plus 1. Correct? 11CR divided by R plus 1 I can write. Summation R is equal to 1 to 9. 11CR. Summation R is equal to 1 to 9. 11CR divided by R plus 1. Correct? R is equal to 1 you put. 11C1 by 2. R is equal to 2. 11C2 by 3. Last term is R is equal to 9 you put. 11C9 divided by 10. So I'll get this. Now using the important property of binomial coefficient, already mentioned earlier once. I used it in the second question I think. Correct? In the second question or somewhere I used the property of binomial coefficient. The first question somewhere, no here. In third question I used NCR equal to N by R into N minus 1 C R minus 1. I'm using this property. Okay? This property is useful here. So I'll write once again NCR is equal to N by R into N minus 1 C R minus 1. This property I'm using. So here you can see 11CR by R plus 1. So I'll start with 12CR plus 1. So what is 12CR plus 1? 12CR plus 1 is 12 divided by R plus 1 into 1 less 1 less becomes 11CR. 12 by R plus 1 into 1 less 1 less 11CR. Okay. So what is 11CR by R plus 1? 11CR divided by R plus 1. What is 11CR by R plus 1 from this? What is 11CR divided by R plus 1? 12CR plus 1 divided by 12. Correct? That is 11CR divided by R plus 1. Correct? I'll be using this. 11CR by R plus 1 is 12CR plus 1 divided by 12. That I'm using here. Of which, see this divided by 12 means you keep 1 by 12 outside. 1 by 12. What we have is summation R is equal to 1 to 9. What is 12CR plus 1. So this is equal to 1 by 12 into, here expand this. Put the various values of R. R is 1 till 9, correct summation. So 12C. When you put R is equal to 1, 12C2. Next when you put R is equal to 12, C3 again. Last term will be what? 12C. When you put R is equal to 9, 9 plus 1 is 10. Correct? R is equal to 1, R is equal to 2, R is equal to 3, till R is equal to 9. So I need to find the sum of this. We know sum of the binomial coefficients is 2 power n. I'll be using that one. Here n is 12 now, see. So we know that 12C0 plus 12C1, 12C2, sum of the binomial coefficients 2 power n. Correct? We know this property. NC0 plus NC1 plus NC2, etc. NCn is equal to 2 power n. Sum of the binomial coefficients is 2 power n. So 12C0 plus 12C1 plus 12C2, etc. 12C12 is going to be equal to how much? 2 power 12. But here see, all the terms are not there. What is missing these two if we compare? 12C0 is not there here. 12C0, 12C1 is not there here. 12C12 and 12C11 is not there, ending with 12C10. So you need to find out the sum from 12C2 to 12C10. What is the sum? 12C0 value is 1, correct? 12C1 is 12 because NC1 is n. So 12C1 is 12. Like this it goes on. 12C2, 12C3, like this it goes on. I'll write till 12C10 and 12C11 is there, no? 12C11 is same as 12C1. 12C1 is 12 and 12C12 is 1. 12C11 is same as 12C1. 12C1 is 12. 12C12 is 1 is equal to 2 power 12. This is 13. This is also 13. So 13 plus 13 is 26. So this is going to be equal to how much? 2 power 12 minus 26. 12 plus 1, 13. 12 plus 1, 13. 13 plus 13 is 26. 2 power 12 minus 26. So what I am going to get is 1 by 12 into, this bracket is going to be, from here I got, this is 13. This is also 13. 13 plus 13, 26 taken to other side becomes 2 power 12 minus 26. 2 power 12 minus 26. We can take 1, 2 common and cancel, correct? So this becomes 2 power 11 minus 13 divided by 6, which is 2 power 11 is 2048. 2048 minus 13 divided by 6, which is 2035 by 6, which is 2035 divided by 6. It is in the simplest form. GCD of m comma n is 1. N comma m is 1. GCD means the greatest common divisor. Same as highest common factor. Highest common factor is 1 in this case. That means it is in the simplest form. Further, it's not possible to simplify. But to understand that whenever they tell GCD of n comma m is 1, that means this is in the simplest form. Further, it is not reducible. Further, it can't simplify it. Okay, it's a rational number in the simplest form. So this is in the simplest form because 2035 is not divisible by 6. Correct? It's not a multiple of 6, 2035. Even it's not a multiple of 3 also. It's not a multiple of 2 also. So further I can't simplify. So I can compare this with n by m. So that n is how much? If I compare, n is 2035 and m is equal to 6. So that n plus m, that is equal to 2041. Answer is 2041. Question asked in the year 2024 JEE, 29th of January, first shift. Please make a note of the properties of binomial coefficients. You know, sum of the binomial coefficients is 2 power n, all the 6 you must know. Sum of the binomial coefficients is 2 power n. Sum of odd binomial coefficients is 2 power n minus 1. Sum of even binomial coefficients also 2 power n minus 1. All the things you must know. So I use the property and also I use this beautiful property of binomial coefficient. Very much useful. NCR equal to n by r into 1 less n minus 1 c r minus 1. Because I can generalize this and write like this: 11 c r by r plus 1 general term. R is equal to 1 to 9 will give all the terms, correct? Sum of all the terms. So 11 c r by r plus 1 if you want to find out, start from 12 c r plus 1. So 12 c r plus 1 is 12 by r plus 1 into 1 less 11 c r. So 11 c r by r plus 1 is 1 by 12 into 12 c r plus 1. Then apply summation and write the terms and use the properties of binomial coefficient. Here the missing terms are 12c0, 12c1. 12c0 value is 1, 12c1 value is 12, and also last two terms missing here, 12c11 and 12c12. 12c11 is same as 12c1. 12c1 is 12 I wrote. This is 12c11 value. This is 12c12 value. Okay, 13 plus 13, 26 taken that side. So 2 power 12 minus 26. 2 is common and cancel it. Okay, and write in the simplest form and compare and get the answer. Hope it's clear. I'll do this problem by another method. Using integration also I can do. See, you can see integral of x, x square by 2. Integral of x cube is integral of x square by 2. Integral of x square is x cube by 3. Integral of x cube is x power 4 by 4. Somewhat like that you can see the numbers, see divide by 2, divide by 3, etc. So because there is 11c1, 11c2, etc., 11c11, I'll consider the expansion of 1 plus x power n. Binomial expansion and integrate that with respect to x and integrate from 0 to 1 using the definite integral. I can get the answer for this. I'll do by another method. Okay, alternate method also I'll teach you. So to do this, consider the expansion of 1 plus x power n. Consider 1 plus x whole to the power n. In fact, I'll consider 1 plus x power 11 because you can see 11c1, 11c2. I'll consider 1 plus x power 11 the expansion. The expansion of this using binomial theorem is 11c0 plus 11c1 into x plus 11c2 into x square. Like this it goes on. What we have is last term 11c11 x power 11. Powers of 1 are not shown because power of any power of 1 is 1 only, correct? So 1 to the any number is 1, 1 into x, 1 into x square, like that. So last term will be 11c11 x power 11. 11c11 x power 11. Correct? Expansion of this we have 1 plus x whole power 11. Now we shall integrate this with respect to x from 0 to 1, applying limits. So integral from 0 to 1 you consider. Integral from 0 to 1, 1 plus x whole to the power 11 is equal to, integrate this with respect to x from 0 to 1, 11c0 plus 11c1 into x plus 11c2 into x square. Like this it goes on. Last term is 11c11 x power 11. Okay, integrate this. Integral of 1 plus x power 11 is 1 plus x power 12 by 12. Integrating using 1 x power n formula. X power n plus 1 by n plus 1. Correct? Divide by coefficient of x, of course. This will be 1 plus x to the power 12 divided by 12. Limits from 0 to 1. 0 to 1. Integral of 11c naught is 11c naught into x. Integral of this 11c naught into x. Correct? Limits from 0 to 1. I'll write. Next 11c1 into this will be x square by 2 plus 11c2 into integral of x square is x cube divided by 3. Like this it goes on. Last term is 11c11 into integral of x power 11 is x power 12 divided by 12. Limits from 0 to 1. Correct? Evaluate the function at upper limit minus lower limit. Put x equal to 1. 1 plus 1 is 2. 1 plus 1 to 2 power 12 minus put x equal to 0. 1 plus 0 is 1. 1 to the power 12 is 1 divided by 12. Putting x equal to 1 upper limit minus lower limit. When you put x equal to 1, 1 plus 1 2. 2 power 12 by 12 minus 1 plus 0. 1. 1 power 12 is 1. 1 by 12. So upper limit minus lower limit. Now for this, evaluate the function at upper limit minus lower limit. Put x equal to 1 minus 0. 1 minus 0 1. 1 square minus 0 square 1. 1 cube minus 0 cube 1. Correct? So all these things I'll write. After applying limits I'll get 11c naught plus 11c1 divided by 2 plus 11c2 divided by 3. Like this it goes on. Correct? Last term is 11c11 divided by 12. Upper limit is 1, lower limit is 0. 1 minus 0 is 1. 1 into that number is that number only. So what is the last term here is 11c9 by 10. So I need to simplify this because some terms are missing here. What is not there? 11c naught is not there. Last two terms are not there. 11c10 by 11 is not there. 11c11 by 12 is not there. So I can write this as 11c naught value is 1. Correct? 11c1 divided by 2 plus 11c2 divided by 3 plus dot. What do you get? This is 11c9 divided by 10 plus 11c10 divided by 11 plus 11c11 is 1 divided by 12. Correct? 11c9 by 10, 11c10 by 11, 11c11 is 1. Correct? 1 by 12. Only this much we want. We want to find the sum from this till this. 11c10 is same as 11c1. Correct? 11c10 is same as 11 minus 10, which is 1, because ncr is equal to ncn minus r. 11c1 is 11. Correct? This is 11. 11 by 11 becomes 1. Correct? This becomes 1 and this also 1. 1 plus 1 2. 2 plus 1 by 12 it becomes. This sum, if you want to find out, this is 11c10 is same as 11c1 because ncr equal to ncn minus r. 11c1 is 11. So this becomes 11 by 11. This value becomes 1. Value of this is 1. 1 plus 1 2. 2 plus 1 by 12. Take it to left hand side. That will be how much? So required sum is 2 power 12 minus 1 by 12. I'll write here 2 power 12 minus 1 divided by 12. This one and this one add up 2 becomes 2 minus 1 by 12. That is my required sum. Yes, I'll write. Correct? So I can take 12 as common denominator. If you take 12 as common denominator, I'll get 2 power 12 minus 1 minus 24 minus 2. I'll get my sum as S is equal to 2 power 12 minus 24 minus 2 minus 26 divided by 12, which is same as 2 power 11 minus 13 divided by 6, which we got the same. Correct? Take common denominator 12. 12 to is 24. Correct? 12 is common denominator. 2 power 12 minus 1 minus 24 minus 1. So 2 power 12 minus 2 minus 24 minus 26 I get divided by 12. This is 2 power 11 minus 13 by 6, which is 2048 minus 13 becomes 2035 divided by 6, which is same answer we got in the previous method also. Same answer we got 2035 by 6. Whichever you find easy, you can do it. Okay. So answer is 2041 in both the case. Compare in the form of n by m. N is 2035, m is 6. 2035 plus 6 is 2041. Okay. So answer is 2041. By using integration also we can get the answer. Looking at the coefficients and the numbers in the denominator, we can identify that, we can integrate a binomial and get the answer. Okay. Or by using the property of the binomial coefficient, we can get the answer. Any method you can try. Hope it's clear. Question asked on 29th of January, first shift. Both the methods are done by integration and by using property of binomial coefficient. Property of binomial coefficient is also easy. Integration also easy. Any method you can try. Okay. No better. Both the methods. Move on to the next one. Remainder when 64 power 32 power 32 is divided by 9 is how much? So want to find the remainder here. So 64 power 32 power 32. I'll write this as 64 to the power 32 to the power 32 is equal to 63 plus 1 to the power 32 to the power 32. Because 63 plus 1 is 64, you know, and 63 is a multiple of 9. I'm dividing by 9. So if you expand this using binomial theorem, okay, all the terms will have 63 except the last term. Only last term does not contain 63. So I can write this as multiple of 63. Of course, you can take this as lambda. This number does not matter for us because 63 is already a multiple of 9. No? So this number, the power does not matter. 32 power 32 is a huge number. We are not worried about that because this 63 is a multiple of 9. If I expand this using binomial theorem, of course 32 power 32 is a huge number. It's a natural number only, some positive number for some positive integer it is. So it's binomial theorem is applicable. So if I expand this using binomial theorem, all the terms will contain 63 except the last term. So I can write this as multiple of 63 plus 1. Multiple of 63 plus 1 because last term is 1. No? 1 to the power, that number is 1 itself. 1 to the power 32 power 32 is 1 itself, correct? So all the terms contain 63 except the last term. If I expand this using binomial theorem. So multiple of 63 means it is divisible by 9 because 63 is divisible by 9. So I can write the remainder obtained as 1. Remainder obtained is 1. Quite simple question. Because if it is multiple of 63, it is also multiple of 9 because 63 is divisible by 9. So remainder obtained here it is 0. 0 plus 1 is 1. Remainder is 1. Answer is numerical type question. Simple one asked on 29th of January, second shift JEE in 2024. Move on to the next one. Number of integral terms in the expansion of this 7 power half plus 11 power 1 by 6 to the power 824. Here the power is even number. So it's very easy to get the answer. I'll do it in detail, okay, this problem because many methods are there for this. I mean, many controversies are there actually. Some of them have done in a different way and done wrong also. I can see in the videos in the YouTube actually. I'll explain this in detail properly. The power is even number does not matter at all. Note that both the numbers 7 and 11 are prime numbers and we are comparing with this form. A power, see what is given is 7 power 1 by 2 plus 11 to the power 1 by 6 to the power of 824. This is comparing with A power 1 by P plus B power 1 by Q to the power N. I am comparing with this. Okay, A and B both are prime numbers. A and B both should be prime number. Then I'm going to apply the shortcut method. Here A is equal to 7. B is equal to 11. And P and Q how much? P is equal to 2. Q is equal to 6. And the power N is 824 given that. The number of integral terms in this expansion when both the numbers A and B are prime numbers. Both A and B should be prime number. The number of integral terms in this expansion is going to be equal to greatest integer value of n by r plus 1. The power is even number, it's guaranteed. Okay. Number of integral terms in this expansion is number of integral terms. Number of integral terms. Number of integral terms is also number of rational terms, both same. Sometimes they'll ask number of irrational terms. In that case, you do total number of terms minus number of rational terms. You get number of irrational terms. Total number of terms in the expansion is 825. Power of the binomial is 824. No? So number of terms is 1 more than the power. So number of terms will be 825. Total number of terms. Total number of terms minus number of rational terms is going to be number of irrational terms. Okay, number of integral terms is same as number of rational terms. Number of integral terms, the formula is greatest integer value of n by r plus 1, where r is going to be LCM of p and q, where r is LCM of p and q. R you have to find out LCM of p and q. So LCM of 2 and 6 you find out. What is LCM of 2 and 6? LCM of 2 and 6 is 6, correct? This is for even, okay? For n should be even. N is even natural number, then only we can do this. This method is applicable only if n is even natural number. So greatest integer value of n by r. N is how much? 824. 824 divided by 6. 824 divided by 6 plus 1. 824 by 6 how much? This is 6 into 13. 6 into 13 is 78. So 1, 3, 4 is remainder, correct? 44. So 137 point something here. 137 point something. Greatest integer value is 137. So 137 plus 1, 138. To understand the scenario of this problem, I'll do it in detail, and also I'll give more illustrations when it is applicable, when it is not applicable, this shortcut method. The power n is even number. The power n is even number, 824. Always remember that number of integral terms in this expansion is greatest integer value of n by r plus 1, where r is LCM of p and q. Both a and b should be prime number. If it is not a prime number, you can convert it to prime number. That is also there. Suppose I give an expansion like this: 2 power 1 by 3 plus 4 to the power 1 by 7 to the power. I'll make this as, otherwise I'll consider this as some other number, 5l, right? Because both should not be same prime numbers. 5 power 1 by 3 plus 4 power 1 by 7 to the power, say 100. 4 is not a prime number. We can convert it to a prime number. 4 you can write 2 square. 2 square power 1 by 7. Then you can apply this result. Okay. 5 is a prime number. 4 is not a prime number. If it is not a prime number, we can write this as how much? 5 power 1 by 3 plus, this is 2 square power 1 by 7. So 2 power 2 by 7 to the power 100. So that now 5 and 2 both are prime numbers, we can apply this result. Okay, so power is even number means always you can apply the number of integral terms or the number of rational terms, both one in the same. Okay, is going to be equal to greatest integer value of n by r plus 1. Both 5 and 2 are prime numbers. You should see the powers denominator. Power of 5 is 1 by 3. So 3 is to be considered. I am comparing with this form. P and Q I want. A power 1 by P plus B more 1 by Q to the power n. So P is 3 and Q is 7. LCM of 3 and 7 is 21. So number of integral terms in this expansion is going to be, number of integral terms in this expansion is going to be equal to greatest integer value of n is 100 divided by LCM of 3 and 7 is 21. Correct? And plus 1 I can add, which is 21, 4s are 84. So 100 by 21 is 4 point something. Integral value of 4 point something is 4. 4 plus 1 is 5. So number of integral terms will be equal to 5. Number of integral terms in this expansion or number of rational terms in this expansion is going to be equal to 5. And moreover, and number of irrational terms, if they ask, total number of terms is 101 because power is 100. Number of terms is 101. 101 minus 5, 96. 96 irrational terms will be there. Okay. If they ask number of irrational terms in this question, number of how many terms are irrational? Number of irrational terms is 101 minus 5. 101 minus 5 is going to be equal to 96. Because power is 100, number of terms in the binomial is 1 more than the power. 100 means 101 terms will be there. Out of that 5 are rational terms, remaining are irrational terms. 101 minus 95 is going to be the number of irrational terms in this problem. Here if you want, 825 terms are there altogether. Number of rational terms or integral terms is 138. So 825 minus 138 will give the number of irrational terms. That also you can note down. Also I'll do this problem by using the general term formula. TR plus 1 formula, I'll use that and explain to you how it is happening this case. Okay. So for that, I'll wrap this part and write TR plus 1 formula and apply that formula and find the values of R for which the powers of 7 and power of 11 both should be integers so that we get the integral terms. Okay. We get integral terms. So writing the general term TR plus 1 formula, TR plus 1 formula is what? TR plus 1 is equal to NCR A power n minus R B power R. NCR A power n minus R B power R. N is how much? N is 824, correct? Power is 824. 824 CR. A is how much? 7 power half. 7 power half. To the power 824 minus R. B is how much? 11 power 1 by 6. 11 power 1 by 6 to the power R. So what do you get? This is equal to 824 CR. This is 7 to the power 824 minus R divided by 2. 11 to the power R by 6. Correct? Power of 7 and power of 11 both should be integers so that we get integral terms. The power of 7 is a fraction if it is a non-integer, and the power of 7 is non-integer, then it becomes a irrational terms. Even power of 11, if it is not an integer, then it becomes irrational terms. Both the power of 7 and power of 11 should be integer so that I get rational terms or integral terms. Okay, so here what are the possible values of R if you want? I can start with R equal to 0. R can take values from 0 to 824 maximum. Out of those values of R from 0 to 824, for which value of R I get integral terms, you should see. Integral terms means the power of 7 and power of 11 both should be integer. So which values are R is possible? R equal to 0 is possible, correct? 0. 824 minus 0 by 2 is integer. 0 by 6 is 0 integer. Next will be 2 and 6 LCM is 12, correct? 12, 24, like that it goes on. Last number will be 824 is not divisible, it's not a multiple of 12, correct? So last number will be how much? 820, is it possible? 824, how much? What is the remainder we got here? 13, 4 carry. 822 is going to be the last number. 822 is multiple of 12, correct? 12 sevens are, 12 six are is 72, 12 sevens are, how much? 12 into 6, 72, 10 carry, 102, 12 70s are. So I'll get 137, correct? Multiples of, I should write multiples of 6, no, sorry. I should write multiples of 6, not 12. I should write multiples of 6 here. Because LCM of 2 and 6 is 6. 2, 6, 12, etc. It goes till 822. 822 is last number. 6 13s are 4 carry, 6 7s are 137. So if we count these number of terms, it is going to be 138. 138 terms. That is what we got. Okay. If the power is even number, it's easy actually. The power is odd number, it matters. I'll give examples here. Okay. I'll give examples to make you understand. This concept is very important because many times questions are asked based on this. I'll add one page here and write a few examples for you. I made some analysis of this, okay, with even numbers and odd numbers. I'll give some examples. We consider the expansion of 2 power 1 by 3, 2 power 1 by 3 plus 3 power 1 by 4 to the power 23. Okay. Next one, I'll write 2 power 1 by 5 plus 5 power 1 by 2 power 23. 2 power 1 by 5 plus 5 power 1 by 2 to the power 23. I'll take only examples with odd numbers first, okay, to make you understand. Next, I'll take 5 power 1 by 2 plus 7 power 1 by 3, 5 power 1 by 2 plus 7 power 1 by 3 to the power 91. Take these examples and analyze how many of them are going to be the rational terms or the integral terms. We'll consider these examples first, then I'll give more examples to make you understand and analyze the situation, what is happening in this situation, in this scenario. Okay, so now here both 2 and 3 are prime numbers. Here both 2 and 5 are prime numbers. 5 and 7 both are prime numbers. And the powers everywhere are given odd numbers only. The power is even number, it's guaranteed that number of integral terms is greatest initial value of n by r plus 1, where r is LCM of p and q. Here, if you write the general term tr plus 1, in this case tr plus 1 is going to be equal to ncr, n is 23, 23cr a power n minus r, a is how much, 2 power 1 by 3, correct, to the power 23 minus r, and b power r, 3 power 1 by 4 to the power r is equal to how much, 23cr 2 to the power 23 minus r divided by 3 into 3 power r by 4. Like this I get. Power of 2 and power of 3 like this. So here power of 2 and power of 3 both should be integers so that I get integral terms or the rational terms. So what are the possible values of r? Can you put r equal to 0? 23 minus 0 by 3 is not an integer. 0 by 4 is integer. So what is the first value of r I can put? I can put r is equal to, r should be multiple of 4. Also it should be multiple of 3. Correct? R is not multiple of 3 I can give. R is multiple of 4 is guaranteed. Correct? And can I put r is equal to 8? 23 minus r by 3 and r by 4 both should be integers here. Both should be integer. The first possible value of r is going to be equal to how much? 8 is possible, no? R equal to 8 is possible. 23 minus 8, 15 by 3 integer. 8 by 4 integer. Next value of r is going to be 20. Correct? 20 is possible. 12 is not possible. 12 is not possible. 16 is not possible. 20 is possible. Correct? Only two values of r I can put because maximum value of r is 23. Then beyond that I can't go. Only two values. If you apply the shortcut method here, if you are applying the shortcut method, greatest integer value of n by r plus 1. N by r is how much? N by r plus 1 is a shortcut, correct? So n is how much? 23. My shortcut formula is greatest integer value of n by r plus 1. N is how much? N is 23. N is 23. R is LCM of 3 and 4. LCM of 3 and 4 is 12. 23 by 12 is 1 point something. Integral value of 1 point something is 1. 1 plus 1 is 2. This formula works. Here also I am getting only two rational terms or two integral terms. By using the shortcut method also I am getting the same thing. Here you write the general term. TR plus 1. This R is not same as this R. That's different. Here R is LCM of P and Q. Okay. R is LCM of P and Q. Notations, don't get confused. LCM of P and Q. P and Q are 3 and 4 here. A power 1 by P plus B power 1 by Q. A power 1 by P plus B power 1 by Q to the power n I'm comparing. P is 3, Q is 4. In that case, the notation is like that. Here NCR, write the formula. 23CR. Here 2 power 1 by 5 to the power 23 minus R. B power R. 5 power half to the power R. Is equal to how much? 23CR 2 power 23 minus R divided by 5 into 5 power R by 2. Both the powers of 2 and 5 should be integers for rational terms or integral terms. So what are the possible values of R? Can you put R equal to 0? Not possible. 23 by 5 is not integer. R equal to 0? Not possible. R should be multiple of 2. Correct? That is guaranteed. What are the possible values of R? So that both the powers of 2 and 5 are integers. Can I put R is equal to 4? Not possible. 6? Not possible. R is equal to 8 is possible. Correct? 8 is possible. Next number is going to be LCM of 5 and 2 is 10. Next number is 18. Correct? 13 is not possible. 18 is possible. Only two values of R is possible. Next number is 28. 28 is not there because last number is 23 there. R value maximum I can put is 23. Only two rational terms are there. This. If you apply the shortcut method here, shortcut method is greatest integer value of n by R plus 1. Correct? N is how much? N is 23. N is 23. And R is going to be LCM of 2 and 5. LCM of 2 and 5 is 10. Plus 1. Correct? This is how much? 23 by 10 is 2.3. Integral value of 2.3 is 2. 2 plus 1 is 3. Here see, I am getting only two rational terms. Here I am getting 3. It's not matching here. Shortcut method doesn't work in this case. Here it works. And some videos I have seen that they tell that r is equal to 0. If it becomes integer, then you write the formula as greatest is the value of n by r plus 1. If r is equal to 0, it works. Where r equal to 0 doesn't work here. Then you don't have to add 1, no? According to that, some videos I've seen in the YouTube. So greatest is the value of n by r plus 1 formula doesn't work. Here it works. Here it doesn't work. That means for odd numbers it's not guaranteed. For odd numbers it's not guaranteed this formula. Better do the actual method whenever they give odd numbers. If it is even number, I can guarantee that this formula. Okay, don't have to check for r equal to 0 also. For even number is 100% sure. Okay, here you see what is my general term. TR plus 1 is equal to NCR a power n minus r a power n minus r into b power r. Correct? So this becomes how much? 91 CR 5 to the power 91 minus r divided by 2. Here 7 to the power r by 3. What are the possible values of r for which both the powers of 5 and 7 are integers? First value of r is going to be equal to 0 doesn't work, correct? It should be multiple of 3, I can give guarantee. R is equal to 3. R is equal to 0 is not possible, right? 91 by 2 is not integer. R equal to 3 is possible, I think. R is equal to 3 is possible because 91 minus 3, 88 by 2 is integer. Next number is LCM of 2 and 3 is 6. So next number is 9. 6 is not possible. 9 is possible. 9, 15, like that it goes on. Last number will be 91 is last value of R. So it will be 87, I think. Correct? Multiple of 3 plus 3. 87 is last number. And if we count the number of terms here it is going to be how much? 3, 9, 87 minus 3, 84. 84 is equal to n minus 1. 15 terms are there here. Correct? 15 terms are there. How many terms are there? 15 terms. And A forms an AP, no? Nth term equal to A plus n minus 1d. 87 minus 84 equal to n minus 1 into 6. N equal to 14 plus 1, 15 terms I get. If you use the shortcut method says that greatest integer value of n by r plus 1. N is how much? The power is 91. And r is going to be LCM of 3 and 6. LCM of 3 and 2. LCM of 3 and 2 is 6. Correct? This is 15 point something. Greatest is value of 15 point something is 15. 15 plus 1 is equal to 16. It fails. Fails here. Here I am getting 15 terms, but here 16. So you should not take plus 1 here. It's not matching. Here it matches. In this case it matches. Here it doesn't match. Here it doesn't match. Correct? That means r equal to 0 is not possible. Yes. Here also r equal to 0. If you take, it is not an integer. Where is my formula? My formula is wrong. Correct? Here it works. Here it doesn't work. Here I am getting 2 rational terms. Here I am getting 15 terms as rational. But there I am getting 16. So many more examples are there. You can try if you want. For whereas the power is even number, no, in that case it works. In that case it works. Many examples are there. I'll write down the examples and take it as a homework, okay? Find the number of rational terms in all these cases. 5 power 1 by 2 plus 7 power 1 by 3 to the power 93. 5 power 1 by 2 plus 7 power 1 by 3 to the power 94. Like that. If it is even number, definitely that formula works. Shortcut formula works. Odd number, take care. Okay, count the number of terms better by writing the general term. 5 power 1 by 2 plus 7 power 1 by 3 to the power 97. Like that you can try many other questions. 8 power 1 by 45 plus 9 power 1 by 7 to the power 129. 9 is not a prime number. 8 is also not a prime number. You should simplify both of them. Okay. Then you can find out. Like that you can find out many other examples you can try. All odd numbers, one of them is even here, rest all odd numbers are given. If you want, you can give another example where it is 2 power 1 by 5 power half plus 7 power 1 by 3 to the power 95. So try all these things as homework, finding the number of rational terms or integral terms. Okay. If they ask irrational terms, then you can find out total number of terms minus number of rational terms is going to give number of irrational terms. Try all these things as homework. Okay. Everything are given as 5 and 7 as prime numbers except this. Here are 2 cube power 1 by 45, 3 square power 1 by 7. Convert both 8 and 9 in terms of prime number and do it. Want the next one? So don't apply the shortcut method when if it is power is odd number. If it is even number, you can apply the shortcut. Okay. So this question is a faulty question actually. They told 2 minus p, 2 minus alpha, alpha, the coefficients of 4 consecutive terms in this expansion. Okay. This question is dropped out because data is inconsistent. So I won't be working out this question. Data is inconsistent. Okay. So we can't solve the equation. We can't find the values of p and alpha. Data is inconsistent. It is dropped by NTA too. So won't be solving this question. Go on to the next one. So alpha is equal to summation k equal to 0 to n. Actually, I've changed the option and given, I think, because this is the wrong question given actually. Some other option was there, I think. And I've changed the option and given like this. Data is inconsistent. This is a question based on the binomial coefficient here, properties of binomial coefficient. Alpha and beta given like this. So I'll be using this formula, NCR. NCR is equal to n by r into, already I used 2 times. N minus 1 CR minus 1. I'll be using this. Okay. So alpha is equal to 1. Summation k equal to 0 to n is there. Summation k is equal to 0 to n. NCK the whole square is split NCK into NCK by k plus 1. Okay. NCK into NCK divided by k plus 1. Okay. So NCK by k plus 1 I want to simplify. So to simplify NCK by k plus 1, you consider n plus 1 ck plus 1. What is n plus 1 ck plus 1? Using this formula. That will be n plus 1 by k plus 1. N plus 1 by k plus 1 into 1 less NCK becomes. Correct? So what is NCK by k plus 1? NCK by k plus 1 is 1 by n plus 1 into n plus 1 ck plus 1. From this, you find out NCK by k plus 1 is how much? This is equal to summation k is equal to 0 to n NCK into NCK by k plus 1 how much? NCK by k plus 1 is n plus 1 ck plus 1 divided by n plus 1. N plus 1 c k plus 1 divided by what? N plus 1. Correct? This will bring it down. So that NCK by k plus 1 I can find out. I am finding NCK by k plus 1. N plus 1 ck plus 1 by n plus 1. So this is equal to, this denominator n plus 1 keep outside the summation. So I'll get 1 by n plus 1. 1 by n plus 1. Summation of k is equal to 0 to n. NCK is same as NCN minus k. Using NCR equal to NCN minus r. We know this. NCR is same as NCN minus r. So I'm using NCK as NCN minus k. Okay. Into n plus 1 ck plus 1. For timing, you should learn this as a shortcut method or a formula. Okay. The product of these two. I'll give a method, okay, I'll prove it later in a synopsis. Should just for timing, just remember summation of NCR into MCS is going to be equal to M plus R CK. M plus R CK, where K is R plus S. Where K is equal to R plus S. It's going to be a constant. So I'm using this result, okay. Summation of NCR into MCS is going to be, just add these two, M plus R, CK, where K is R plus S. So this product becomes, summation of this product becomes, summation is there, NC n minus K into n plus 1 CK plus 1 becomes, summation of this product becomes, add this and this, n and n plus 1 we need to add, n plus m, no, you add this and this. That is what you wrote. M plus n, sorry. M plus n it is. M plus n ck. Add this value and this value. These two add. So add this and this. What is n plus 1 plus n? That is 2n plus 1. 2n plus 1 c. R and s. If you add this, I should get some constant. Adding n minus k and k plus 1. N minus k plus k plus 1 how much? N minus k plus k plus 1 is equal to how much? N plus 1. Correct? So 2n plus 1 c n plus 1. This is the answer. Alpha value is this much. So learn this. Two important results I am going to apply. I'll rub, resist, all these things. I'll write what are the results used here. One is NCR is equal to n by r into n minus 1 c r minus 1. Another result is summation of MCR into, I use two results. One is NCR is equal to n by r into n minus 1 cr minus 1. This result. And another one is summation of NCR into MCS is equal to M plus N C R plus S, which is K, where K is equal to R plus S. These are the two results I used. Okay, NCR into MCS, summation of this product is M plus N, this plus this, C, this plus this. Just remember, add these two, n plus 1, this value and this value add, C, n minus k plus k plus 1, okay, n plus 1. This is alpha value. Same way you simplify beta here. Beta also same way you simplify. NC k plus 1 by k plus 2 is there. Now to simplify this, we consider n plus 1 c k plus 2. What is n plus 1 c k plus 2? This is going to be equal to what? N plus 1 divided by k plus 2 into 1 less, that is n c k plus 1. Correct? Can I use this? So n c k plus 1 by k plus 2 will be n plus 1 c k plus 1 by n plus 1. Using this in beta, I'll get beta is equal to summation k equal to 0 to n minus 1. Summation k equal to 0 to n minus 1. Correct? So using this, n c k plus 1 divided by k plus 2 is 1 by n plus 1 into n plus 1 c k plus 2. Correct? So n plus 1 c k plus 2, n plus 1 c k plus 2 divided by what we have? One more nck is there. I'll write that. I'm writing this part first. nck plus 1 by k plus 2 I'm writing into nck is there. Correct? Divided by n plus 1. This 1 by n plus 1 keep outside and use nck as nc n minus k. So beta becomes 1 by n plus 1 keep outside, summation of k is equal to 0 to n minus 1. nck is same as nc n minus k. nc n minus k into n plus 1 c k plus 2. So summation of this product is what? I want to use this. NCR MCS, using this, add this and this, n plus 1 becomes 2n plus 1, this value plus this value, 2n plus 1, this value plus this value, minus k plus k will cancel, n plus 2 it becomes. So I am getting n plus 1 by n plus 1, 1 by n plus 1, summation of this product using this formula, I am getting this as this plus this, n plus 1, how much? 2n plus 1, 2n plus 1, C, n minus k plus 2 will be n plus 2. Correct? So alpha and beta we got like this. And further they given 5 alpha is equal to 6 beta. Use this. Okay? Alpha and beta, substitute in this. Want to find the value of n in this. So I'll use this equation and I erase this part once again. This is not required anyway. 5 alpha is equal to 6 beta. Correct? Using this. Given 5 alpha is equal to 6 beta. 5 into alpha, how much? Alpha is 1 by n plus 1 into 2n plus 1 cn plus 1. 2n plus 1 cn plus 1 is equal to 6 into beta is 1 by n plus 1 into 2n plus 1 cn plus 2. 2n plus 1 cn plus 2. 1 by n plus 1 is going to cancel, correct? Both identical terms. Then I'll be using one more result here. NCR by NCR minus 1 is n minus r plus 1 by r. I'm using that. Okay, note down this result. NCR divided by NCR minus 1 is equal to n minus r plus 1 divided by r. Isn't this? N minus r plus 1 by r. So I can cancel 1 by n plus 1 and write this as 5 by 6 is equal to 5 by 6 is equal to 2n plus 1 cn plus 2, 2n plus 1 cn plus 2 divided by 2n plus 1 cn plus 1. Correct? So using this result now, NCR divided by NCR minus 1 is n minus r plus 1 by r. I'll use this formula, okay, here. Instead of n, I got 2n plus 1. And instead of r, I got n plus 2. R minus 1. N plus 2, n plus 1. So ratio of this is going to be how much? In place of n, you put 2n plus 1. So we can write here itself. Can erase this part also. So they may not required. This ratio is going to be equal to how much? Two n plus 1, n is 2n plus 1 minus r is n plus 2 minus of n plus 2 plus 1 divided by r is n plus 2 here, correct? N is 2n plus 1, r is n plus 2. Simplify. Plus 1 plus 1 plus 2. 2 minus 2 will be 0 here. 2 minus 2 0. 2n minus n is n. So I'll get 5 by 6 equal to 5 by 6 is equal to 2n minus n is n plus 2 minus will cancel out, n by n plus 2. Cross multiply and simplify this. How much you get? 5n plus 10 is equal to 6n, or 6n minus 5n. So n is equal to 10 I'll get. Value of n is 10. Numerical type question asked on 30th of January, second shift, JEE Main 2024. Please make a note. Just using the properties of binomial coefficient. We use NCR by NCR minus 1 as n minus r plus 1 by r to simplify it last. In the beginning I used NCR is equal to n by r into n minus 1 cr minus 1, and also use summation of NCR into MCS is equal to m plus n ck. Which are the results I used? I just mentioned here. I use these results. Results used in this problem are, one is NCR is equal to n by r into n minus 1 cr minus 1. This result is used. And further I use this summation of NCR into MCS is going to be equal to m plus n cr plus s. Okay, this plus this, you know, this plus this. Summation is not there, only this. And we use NCR divided by NCR minus 1. NCR divided by NCR minus 1 is equal to n minus r plus 1 divided by r. These are the three results I used to simplify this problem. Okay, is that clear? Please make a note of this. Question number 10 is completed. Value of n is 10, satisfying this equation. Move on to the next one. Question number 11. In the expansion of 1 plus x into 1 minus x square into this, sum of the coefficients of x cube and x power minus 13 you have to find out. So simplify this bracket. Third bracket will simplify. Okay, 1 plus 3 by x. If we simplify, 1 plus 3 by x plus 3 by x square plus 1 by x cube. whole to the power 5 is there. Here take LCM x cube. So this will be x cube plus 3x square, correct? Because 1 means 1 by 1, 1 into x cube into 1, x into x square, that x square to multiply this, x square to multiply by x, so I get 3x plus x cube into 1, 1 into 1, whole to the power 5. This is what? 1 plus x the whole cube. This is the expansion of 1 plus x the whole cube, correct? 1 plus x the whole cube to the power 5 divided by x cube is equal to how much? 1 plus x whole to the power 3 into 5 is 15 divided by x cube. Numerator is x power 15, sorry, correct, x power 15. Whole cube is there, no? X power 15 it is. X cube power 5 is x power 15. X power 15, like this I get. Numerator is raised to the power 5, even denominator is also raised to the power 5. So I get like this, correct? So now if you simplify this, what I get? The given expression will write JEE. JEE is equal to 1 plus x, keep as it is. 1 minus x square, we can write it as 1 plus x into 1 minus x, correct? 1 plus x into 1 minus x. 1 minus x square. This part simplification is shown here, correct? 1 plus x power 15 by x power 15. Correct, no? 1 plus x whole power 15 divided by x power 15. Like this we get. Now, I can merge some of the terms. I can multiply these two. 1 plus x into 1 plus x. 1 plus x the whole square. 1 plus x the whole square into 1 plus x power 15 becomes 1 plus x power 17. This is further simplifiable. 1 minus x into 1 plus x to the power 17. Whole thing is divided by x power 15. That means to find coefficient of sum of the coefficient of x power 3 and x power minus 13. If you want to find coefficient of x power 3 in this, I have to find coefficient of x power 18 in the numerator, correct? Coefficient of x power 3, coefficient of x power 3 in the above expansion in star I'll call, in star. Coefficient of x cube in star is same as coefficient of x to the power how much? 18. Coefficient of x power 18, because 18 by 15, x power 18 by x power 15 becomes x cube. So x power 18 in this product, 1 minus x into 1 plus x to the power 17, correct? I have to find coefficient of x power 18 in this. That means that is coefficient of x power 18 you have to find out. Coefficient of x power 18 in which one? 1 into 1, 1 into this, 1 multiplied to 1 plus x power 17. It is 1 plus x to the power 17 minus x into 1 plus x to the power 17. 1 into this minus x into this. Want to find coefficient of x power 18 in this. Here the last term will be 17c 17 x power 17. So there is no term containing x power 18 in this. In this expansion there is no term with x power 18. Here last term in this expansion is 17c 17 x power 17 into x. If you multiply I get x power 18. So here coefficient of x power 18 is 0. Here it is 0. The coefficient of x power 18. Here when you write the last term it will be 17c 17. Before that the powers of x will be less. Highest power of x is x power 17. That x power 17 into x becomes x power 18. The coefficient is going to be equal to, see minus is there, minus you keep as it is, 17c 17 I'm getting. 17c 17, correct? Because if you want I can show it. See x into, if you expand this 1 plus x power 17, the terms will be like this. 17c naught plus 17c 1 into x. Like this it goes on. Last term will be 17C17 x power 17. Correct? So you want x power 18 coefficient, no? Which is found here. X power 17 into x becomes x power 18. When you multiply, the coefficient is 17C17. 17C17 is 1 because NCN is 1. So 0 minus 1. So coefficient of x cube in star, coefficient of x cube, coefficient of x cube. I want to find coefficient of x in this expression in star is going to be equal to 0 minus 1 is going to be equal to minus 1. Next thing I have to find coefficient of x power minus 13 in this star. If you want coefficient of x power minus 13 in this, I will find coefficient of x square in this numerator. Coefficient of x power minus 13 in equation star is same as the coefficient of x square, because x square by x power 15 gives x power minus 13, correct? So want to find coefficient of x square in the numerator. Coefficient of x square in the numerator, 1 minus x into 1 plus x to the power 17. That is the coefficient of, that is coefficient of x square in where? 1 into 1 plus x power 17 is 1 plus x power 17 minus x into 1 plus x power 17. Correct? Like this we get. You want to find coefficient of x square in this, so that we get coefficient of x power minus 13 in this, because x square by x power 15 is x power minus 13. So if you want to find coefficient of x square, see first term is 17C0 plus 17C1x plus 17C to x square again. So coefficient of x square and this is 17C2, correct? In this expansion, I am going to get 17C2 coefficient of x square. Here, first term is 17C0 plus 17C1 into x. That x into x becomes x square. So coefficient of x square is 17C1 minus 17C1. Correct? Coefficient of x square in this and coefficient of x square in this. 17C2 is how much? 17 into 16 by 2. 17 into 16 by 2. 17 into 8. That is 17 into 6. 17 into 8. That is 136. 136 I'll get. Minus. This is 17C1 is 17. Add these two. Want to find sum of these two. 136 minus 17 is 119. 119 plus minus 1. Coefficient of x power 3 in this expansion and coefficient of x power minus 13 in this expansion. We got here minus 1 and 119. Add these two. We get 118. 118 is answer. Hope it's clear. Finding coefficient of x cube in star is same as coefficient of x power 18 in the numerator. So find coefficient of x power 18 in the numerator of this star. So as shown here. Here there is no x power 18 term. Here last term will be x power 17. Its coefficient is 17C17. So x power 17 into x becomes x power 18. So coefficient is minus 17C17, which is minus 1. 0 minus 1, minus 1. Here I am getting 17C as coefficient of x square in this. Correct? 1 plus x to the power 17 if I expand. 17C0, 17C1x, 17C to x square I get. 17C to x square. Coefficient of x square is 17C2. Here the terms of this bracket is 17C0 plus 17C1 into x. That x into x becomes x square. So coefficient is minus 17C1. Simplify these two values and add these two. 119 plus minus 1, which is 118 is the answer. Question asked on 31st of January, first of JEE mid 2024. Move on to the next one. Given like this, if for some m comma n, properties of binomial coefficient you apply here. Okay. Properties of binomial coefficient. Here, go and simplify this. I'll be using this property NCR plus NCR minus 1. NCR plus NCR minus 1 is equal to N plus 1 CR. 6cm, correct? Simplify this. 6cm plus 2 times 6cm plus 1, you can split this as 6cm plus 1 plus 6cm plus 1. 6cm plus 1 plus 6cm plus 1 plus 6cm plus 2 is greater than 8c3. Is greater than 8c3. I'll combine these two and use this result. NCR plus NCR minus 1 is N plus 1 CR. So 6cm plus 1 plus 6cm. 6cm plus m plus 6cm will be 7cm plus 1. Correct? So combining the first two terms, 6cm plus 1 plus 6cm. Correct? Sum of these two is going to be how much? 7cm plus 1. Correct? R is m plus 1, R minus 1 is m. N is 6, n plus 1 becomes 7. So combining these two, I get 7cm plus 1. Same way, combining these two, I'll get 7cm plus 2. Correct? 6cm plus 2, 6cm plus 2 plus 6cm plus 1 is going to be equal to how much? 6 becomes 7, cm plus 2. So the sum is combining these two, I get 7cm plus 2 is greater than 8c3. Again apply the same result. NCR plus NCR minus 1, N plus 1 CR. If I add these two, I'll get 8cm plus 2. 8cm plus 2 is greater than 8c3. 8c3 is 8 into 7 into 6 by 6, which is 56. The value of this is 56, 8c3. If you take m is equal to 1, it becomes 8c3. 8c3 is greater than 8c3, not possible. M is equal to 1 does not satisfy because both left hand side and right hand side becomes equal. If you take m is equal to 2, 2 plus 2 is 4. 8c4 is 70. 70 is greater than 56, possible. For m is equal to 2, for m is equal to 2, 8c, I'll get 2 plus 2, 4, which is 70, okay, which is greater than 56. 8c4 you can calculate. 8 into 7 into 6 into 5 divided by 4 factorial. 8c4 if you want the calculation. 8 into 7 into 6 into 5 divided by 4 factorial is 24. 6 ones are 6 fours are 4 ones are 4 twos are 2 into 7 14 into 5 70. So m is equal to satisfies. If you take m equal to 3, again it is not satisfying. So m equal to 3 if you take, it becomes 8c5. 8c5 is same as 8c3. They will become equal. They won't be, this will be not be greater than this. So m is equal to 2 is the answer. M is equal to 2 is the answer for this in equation. And given n minus 1 p3 is to n p4 is 1 is to 8. Find n value from this. Also given n minus 1 p3. Correct? N minus 1 p3 divided by np4 is equal to how much? 1 by 8. N minus 1 p3 means n minus 1 into n minus 2 into n minus 3, going 3 times back, divided by np4 is n into n minus 1 n minus 2 into n minus 3, which is given to be equal to 1 by 8. N minus 1, n minus 2, n minus 3 is going to cancel. What you get is 1 by n is equal to 1 by 8. That means n is equal to 8. Taking reciprocal, we got the value of n and we got the value of m. M is 2, n is 8. Correct? M is 2 and n is 8. These values of m and n you can substitute in this and get the required answer. npm plus 1 plus n plus 1 cm you have to find out. Required is npm plus 1 plus n plus 1 cm, n plus 1 cm. What is n? N is 8. 8 p m is 2. 2 plus 1 3 plus n is 8. 8 plus 1 9. C m is 2. 8p3 calculate. 8p3 is 8 into 7 into 6. 8 into 7 into 6. 9c2 is 9 into 8 divided by 2 factorial. This is 2. Correct? 8 into 7, 56. 56 into 6 is 336. Plus 2 ones are 2 fours. 4 into 9 is 36. So this is going to be 372. Answer is 372. Quite simple question. Just basic properties of NCR. Just using NCR plus NCR minus 1 equal to N plus 1 CR. Repeatedly I am applying this 3 times. Combining these two, and answer of these two again apply. And by inspection method you can see which value of M is going to satisfy. And solve another equation. The ratio is given here. N minus 1, P3 is to N, P4 is 1 is to 8. From there you get the value of N. N and M, substitute, get the answer. Over. Very simple question. Move on to the next one. I think this is the last question, 13th one. Coefficient of x power r in the expansion of this type of question also asked many times. Finding sum of the series using GP. This forms a geometric progression, geometric series. Sum to n terms of GP to apply the formula. Sn is equal to a into 1 minus r power n by 1 minus r. If common ratio is not equal to 1. Sn for GP I am going to apply. A into 1 minus r power n divided by 1 minus r. If the common ratio is not equal to 1. Common ratio is not equal to 1. I am applying this formula. Okay. So here this forms a GP here. See, power of x plus 3 is n minus 1. Power of x plus 3 goes on decreasing. Here x plus 2 was not there. Here x plus 2 starts. X plus 2 power keeps on increasing. Last term is x plus 2 power n minus 1. Correct? Starts with x plus 3 power n minus 1. And last term is, we can consider into 1. Into 1 if we consider x plus 3 power 0. X plus 3 power n minus 1 to x plus 3 power 0 means the power of x plus 3 is varying from 0 to n minus 1. 0 to n minus 1 means there are n terms. Correct? Apply Sn for GP here. Given sum forms a GP here. Correct? So I'll apply sum to n terms of GP. Let this sum be equal to Sn. I'll call Sn. Okay? Let Sn be equal to this. Sn be equal to this. If you want I can write this. X plus 3 to the power n minus 1. Let Sn be equal to this. Sn be equal to this. X plus 3 to the power n minus 1. X plus 3 to the power n minus 1 plus x plus 3 power n minus 2 into x plus 2. X plus 3 to the power n minus 2 into x plus 2. Correct? Next term is x plus 3 power n minus 3 into x plus 2 the whole square. X plus 3 to the power n minus 3 into x plus 2 the whole square. Like this it goes on. Last term is x plus 2 to the power n minus 1. How many terms are there? N terms. Forms a GP. Forms a geometric series. The first term is x plus 3 power n minus 1. And common ratio is x plus 2 by x plus 3. If you want to find the ratio between the two consecutive terms, second term or first term, or third term or second term, common ratio is x plus 2 by x plus 3. With first term, a is equal to x plus 3 to the power n minus 1. Common ratio is x plus 2 divided by x plus 3. So, sum to n terms formula is going to be equal to, first term we write, use this formula, a into 1 minus r power n by 1 minus r, using this. A is the first term, r is the common ratio. First term is x plus 3 power n minus 1. X plus 3 to the power n minus 1 into 1 minus common ratio x plus 2 by x plus 3. Correct? If you want to divide the second term by first term, x plus 3 power n minus 2 cancels, x plus 3 remains because x plus 3 power n minus 1 is bigger than x plus 3 power n minus 2. So 1 x plus 3 remains there. So 1 minus x plus 2 by x plus 3 to the power n. Number of terms is n. Divided by 1 minus common ratio is x plus 2 by x plus 3. Simplify this. What we get? X plus 3 to the power n minus 1. Here take LCM. I'll get x plus 3 to the power n minus x plus 2 to the power n divided by x plus 3 to the power n. And here if you take LCM as x plus 3, I get x plus 3 minus x plus 2 by x plus 3. X plus 3 minus of x plus 2 divided by x plus 3. Here x plus 3, 1 will cancel. If we cancel x plus 3 here, this becomes x plus 3 power n minus 1. That x plus 3 power n minus 1 will cancel with this and this. So denominator is x minus x 0. 3 minus 2 is 1. Denominator is 1. No need to write it. So this becomes equal to how much? Numerator is x plus 3 to the power n minus x plus 2 to the power n. Like this we get Sn. X plus 3 power n minus x plus 2 power n. This is sum to n terms. Correct? So there I have to find the coefficient of x power r. Instead of finding coefficient of x power r in this so much all the terms, I am taking the sum of this. Actual method is you have to find coefficient of x power r in this bracket, then find coefficient of x power r in this bracket, coefficient of x power r in this bracket. Like that you have to find coefficient of x power r in each term. Each term you have to find the coefficient of x power r and then take the sum. Instead of that, that becomes lengthy and it is time consuming, correct? So we can't find so easily. So because we don't know the value of r there, correct? So finding out that is not so easy. So what I am doing is I am finding the sum first and then finding the coefficient of x power r in that sum. So finding sum of this, we got like this. So now we can find coefficient of x power r in this. So what is coefficient of x power r in this? Use TR plus 1 formula. This is same as 3 plus x to the power n. Same as 3 plus x to the power n minus 2 plus x power n. You can write like this. If you want, you can use the TR plus 1 formula here. What is my TR plus 1 formula? NCR, a power n minus r, b power. So 3 plus x power n, general term will be, general term is NCR, correct? A power n minus r into b power r, b is x, x power r. General term in this I wrote. So coefficient of x power r in this expansion is NCR 3 power n minus r. Likewise, coefficient of x power r in this NCR 2 power n minus r. In this expansion, if you write the general term NCR a power n minus r b power r, a is 2, b is x. Compare this with a plus b power n and write the general term. So the coefficient of x power r in this expansion is going to be, so I'll write the coefficient of x power r now. Therefore, coefficient of x power r in 3 plus x to the power n minus of 2 plus x to the power n is going to be equal to NCR into 3 power n minus r. In this it will be NCR into 2 power n minus r. Likewise, looking at this general term of this expansion, I wrote the coefficient of x power r, NCR 3 power n minus r. So coefficient of x power r in this expansion is NCR 2 power n minus r. Okay, so that is given to be equal to alpha r. This is alpha r according to the question. This is your alpha r. Coefficient of x power r is alpha suffix r. Want to find summation r is equal to 0 to n alpha r. That is beta power n minus gamma power n. Beta and gamma are natural numbers. So I have to find out beta square plus gamma square. So this is summation you take for this. Summation r is equal to 0 to n. Summation r is equal to 0 to n. Alpha r is equal to summation of r is equal to 0 to n. NCR, I can write 1 to the power r into 3 power n minus r minus summation n is equal to r is equal to 0 to n. R is equal to 0 to n. Summation r is equal to 0 to n. What we have? NCR into 1 to the power r I can write into 2 power n minus r. This is nothing but expansion of 1 plus 3 whole power n using binomial theorem. This is 1 plus 3 power n. This is 1 plus 2 power n, correct? Using general term. Summation is that r is varying from 0 to n. That means there are n plus 1 terms. This is nothing but the expansion of 1 plus 3 power n using binomial theorem. This is the expansion of 1 plus 2 power n. So using that, I can write this as my summation r is equal to 0 to n alpha r is equal to, can erase this part, it's not required, correct? This is going to be equal to how much? Finally we get this is equal to, this part is going to be equal to 1 plus 3 whole to the power n using binomial expansion. A plus b power n. We know a plus b power n is what? A plus b power n is nothing but summation of r is equal to 0 to n. Summation of r is equal to 0 to n. NCR a power n minus r into b power r. Correct? This is the expansion a plus b power n. So here see NCR a power n minus r b power r, which is 1 plus 3 power n. A is 1, b is 3. You can interchange if you want. First you can write that like that. This is 2 plus 1 power n. Correct? Using this, put b as 1, a as 2. NCR 2 power n minus r, b as 1. A is 2, b is 1. Correct? Interchange and write if you want these two product. This is nothing but 1 plus 2 power n. Using this, correct? I simplified these two. This is 3 plus 1 power n. This is 2 plus 1 power n, which is same as 1 plus 3 power n minus 1 plus 2 power n, which is 4 power n minus 3 power n. Now compare with this beta power n minus gamma power n. Comparing with beta power n minus gamma power n. How much is beta? 4. Gamma 3. Correct? Want to find beta square plus gamma square. Beta is 4. If we compare these two, beta is 4. So 4 square. Plus if we compare, gamma is 3. So 3 square. 4 square 16. 3 square 9. 16 plus 9 is 25. Answer is 25. Question asked on 31st of January, second shift, JEE Main 2024. Please make a note. Very nice question asked. So this type of question is also commonly asked. Minimum 3 or 4 times they ask this type of question. Finding the sum and then finding the coefficient. Using sum to n terms of geometric series. Use common ratio is not equal to 1. Use the formula. Sum to n terms as a into 1 minus r power n divided by 1 minus r. R is common ratio and a is the first term. For common ratio not equal to 1, we can use this. So with this, all the 13 questions of JEE Main 2024 of binomial theorem of January shift is completed. Okay, one question was a faulty question which is dropped by NTA, so I have not solved that question because of data was insufficient. This was the 13th question. Okay, finding the sum of the terms using GP, sum to n terms of GP, and then finding coefficient of x power r, and using summation again using the binomial expansion. This formula is used, a plus b power n, summation r equal to 0 to n, NCR a power n minus r. If you want, you can write this expansion of this 1 plus 3 power n. 1 plus 3 power n is equal to what? Summation of r is equal to 0 to n NCR, correct? 1 to the power n minus r. I can write, interchange these two. If you want, you can write 1 plus 3 as 3 plus 1, right? 1 plus 3 same as 3 plus 1. 3 plus 1 to the power n. So that NCR a power n minus r b power r. That is what is present here, correct? NCR 3 power n minus r into 1 power r. That is 3 plus 1 to the power n, which is same as 1 plus 3 power n. Similarly, this is 2 plus 1 to the power n, same as 1 plus 2 power n. 4 power n minus 3 power n. Compare beta power n minus gamma power n. Beta is 4, gamma is 3. So beta square plus gamma square shown here. Answer is 4 square plus 3 square, which is 16 plus 9, 25. This was the 13th question. And 12th question on just using the property of binomial coefficient NCR plus NCR minus 1 equal to n plus 1 CR. Repeatedly applying it for 3 times and also using another equation, get the answer. And this was a question on finding the coefficient of x power 3 and x power minus 13. And this was some results I wrote. And this is a property of binomial coefficient problem again. This was a question dropped, okay. 10th one, then 9th one was dropped, okay. And 8th one, I explained more examples also given, homework also given, finding number of integral terms. The power is even, greatest initial value of n by r plus 1 is going to be number of integral terms, where r is LCM of p and q. Both a and b should be prime numbers. So a and b both should be prime numbers, 7 and 11, correct? Very important question, this one. Many times questions are asked. And the power is even number, directly we can apply the shortcut method. The power is odd number, don't apply the shortcut, better do the proper method. Also the proper method is explained here. Okay, explained in detail. Move on to the next one. Previous one was remainder problem, and this is property of binomial coefficient done by 2 methods. And coefficient of x power 2012 here. Here sum of the coefficients concept, and here finding out using property of binomial again, binomial coefficient. And this is general term formula TR plus 1 and coefficient formula. So all the questions have been completed. Okay, so 13 questions were there altogether. So binomial theorem 2024 JEE main January shift is completed. Many more videos will be uploaded in the coming days. Please subscribe to my channel and forward to your friends. Thank you.